Hello everyone, so how are you all doing? I hope you all are doing great, and since your exams are near, you must be worried what to practice, what to not, and what questions are important. So here we are with the 50 most important question for your next 2026. So without wasting any time, let us move on to our first question. So this is your first question. What it says, let this denotes the greatest integer function less than or equal to x. Then you have to tell the number of positive integer solution to this particular equation. Now since this is greatest integer and these are equal, so let k be the common integral value for this. So let us assume k is the common integral value. Now by definition of floor function, this is also called as floor function. So by definition of that, this value is between k and k plus 1. Similarly, x by 20 will be greater than or equal to k and less than k plus 1. That is just by the definition of your floor function. So this gives you this inequality and this also gives you this inequality. So now we have these two conditions. So we have these two conditions for this x to satisfy. Now if you look at on the number line, so let's say this is your x, this is your 19k, right? Let's say somewhere 19k. And this is your 20k, that will be greater than 90k, and then 19k plus 1 will be somewhere here, 19k plus 19 will be somewhere here, and then 20k plus 20 will be somewhere here. So now if you want x to be a solution, x should be between 20k to 19k plus 19. So for the solution to exist, two intervals must overlap, the condition that I told you. Now specifically the lower bound of second must be less than the upper bound of the first. So the other condition that should be true is the upper bound of first should be greater than the lower bound of second. So from there you will get this condition, 20k should be less than 19k plus 19. So from here when you solve this, you will get k to be less than 19. So what are the values of k that are possible? 0, 1, 2 till 18. So now for a fixed k, x must satisfy this. From this condition, x must satisfy this equation, right? So for a fixed k, x must satisfy this. So we'll get what? We will get the number of integers in this range is 19k plus 19 minus 20k. So number of integers between an interval. So let's say you have an interval a comma b. So you have this interval of the form a comma b. So number of integers between this interval are b minus a. So that is what is written. So number of integers are 19k plus 19 minus 20k. So you will get what integers? You will get 19 minus k integers. So now when we sum them for all valid k, for k is equal to 0, that is a special case. Why? Let's see. The ranges for k is equal to 0, your range will be what? Your range will be 0 to 19. Your range will be from 0 here to 19 here. So from there it says positive solution. It says only positive solution. So you cannot take 0. So you have to exclude 0. So you will get 1 to 18. You will get from 1 to 18. So you are getting only 18 solution from this particular case. Now for other cases, when k is from 1 to 18. So when your k is from 1 to 18, you just sum these. All you have to do is just sum all these integral solutions. So from k 1 to 18, you just sum them. This 18 solutions are from the case k is equal to 0, and the rest are from this particular case. So when you add them, this will be 18 plus 17 till 1. Now sum of n terms is n plus 1 by 2. So 18 into 19 by 2. So when you solve this, you will get your final answer as 189. So the correct answer for this question is option number C, 189. So this was a very good question. Now let us move on to our next question. It says the equation x cube plus 2x square plus 2x plus 1 is equal to 0 and x to the power 200 plus x to the power 130 plus 1 is equal to 0 have how many common roots? So we have to tell what? We have to tell the common roots of these two equations. So from this I can see this equation is easy to solve. It is a cubic equation, while this is a 200th power equation. So let's solve the first equation. So your first equation, when you factorize it, it will be x plus 1, x square plus x plus 1 is equal to 0. So from here, your roots are x is equal to -1 and x is equal to omega and omega square, where omega and omega square are cube roots of unity, right? One cube root of unity is 1 and these are the other roots where omega cube will satisfy, it will be equal to 1 and 1 plus omega square from this equation will be equal to 0. Now substitute these three roots in this equation. Why? Because we have to find just the common roots. So substitute all these three value in this equation. So check it. For p is equal to -1, it is giving me value 3. It is not equal to 0. You can do this calculation on your own. Now when p omega, when we check the value of this at omega, it will be omega to the power 200 plus omega to the power 130 plus 1. Now 200 can be written as, you can write 200 as 3 into 66 plus 2. So this can be written as omega to the power 3 to the power 66 into omega to the power 2. Now I know omega to the power 3 is what? 1, and 1 to the power 66. 1 to the power 66 is nothing 1, and it will be 1 into omega square. That will give you just omega square, right? So this is how you can break down 200. Similarly, you can break down 130 as a multiple of 3, and by quotient remainder theorem you will get in this form. It will come out to be equal to omega, and 1 is like that. And now I know this particular value is equal to 0. So omega is the root of this, equation. Similarly, omega square, when you put 400 in this format, you will get this equal to omega. You will get 260 as omega square plus 1. Again, this is the same equation. This will also be equal to 0. So this and this, these two roots are common for this equation as well as this equation. So from here, how many common solution you get? From here we get exactly 2 common roots. So exactly 2 common roots are for these two equations. Now let us move on to our third question. This is from your trigonometry. So how many solutions does this equation have in the interval 0 to 2 pi? So you have to check the number of solutions of this equation in the interval 0 to 2 pi. So what we will do, we'll convert this into a quadratic equation. This can be seen as a quadratic. We will convert it into a quadratic equation. What we will do, divide the entire equation by cos square x. So we'll divide this entire equation by cos square x. Why? Because if you see, cos x is not equal to 0. Why? Because if you put cos x as 0, let cos x is equal to 0. This gives what? This gives this is equal to 0, this is 0. So I'll be left with, this implies sin square x is equal to, sin square x will be equal to, the right hand side is also 0. This implies sin x is equal to 0. But cos x and sin x are never 0 together. They never share a common root. So this is contradiction. This cannot be true. This cannot be true when we let cos x as 0. So cos x is not 0. So this is what I will get. So this cannot be true at the same time. So what we will do? We will do what? We will divide it by cos square x. So divide the entire equation by cos square x. So this will be tan square x minus 15 tan x, and this will be plus 50 is equal to 0. Now this is a quadratic equation in tan. Factorize it, you will get 10x minus 5 is equal to 0 and 10x minus 10 is equal to 0. When you factorize it, you will get 2 factors. 10x is equal to 5 and 10x is equal to 10. Now your interval was what? 0 to 2 pi. So you can check the number of solution easily by graph. So your graph of 10 is what? This is 0, this is your pi, this is your 2 pi. So graph of your tan looks like, at 0 it is 0, at pi by 2 it looks like this, then at pi it is again 0 and it will come from down like this, and then it will go like this. Right, this is the graph of your 10x, this is the value at which it is, this is pi by 2 and this is your 3 pi by 2. So this is somewhat the graph of 10x looks like. Now what is your equation? The right hand side is your 10x is equal to 5. So 5 will be somewhere here. When you draw this line, this will cut the graph of 10x at exactly 2 points. Similarly, point 10, it will cut the graph of 10x at exactly 2 points. And if you want to see the period, 10x has period pi, that is true, 10x has period pi, and when each of the value 5 and 10 is attained exactly twice. That's how I showed you how these values are attained exactly twice. So how many solution you get? You get total 4 solution. So the answer of this question is you get total 4 solutions. Now your next question. This is from your set theory. What it says? S be a non-empty set such that total number of subsets of S containing at most 2 elements. How many elements? At most 2 elements, which means 0 element, 1 element and 2 element is 16. So you have to tell the number of elements in set S. So let the number of elements in set be n. We consider it to be n. Then total number of subsets containing at most 2 elements is given by sum of subsets of 0, 1 and 2, right? So total number of subsets having at most 2 element will be subsets with 0 element, with 1 element and 2 element. So what is the formula for number of subsets with k elements? So number of subsets with k element is given by NCK. Number of subsets with k elements, number of subsets with k elements is given by this. So put k is equal to 0, 1 and 2. So this is how we represent this. This is can also be represented as nk. So this is another representation of this formula. So this will be nc0, nc1, nc2 is equal to 16. Just solve this. This value is 1, this value is n, and this will open as n plus n minus 1 by 2. So this is the value, it is equal to 16. Now form the quadratic. This will be 2 plus 2n plus n square minus n is equal to 32. And when you solve this further, you will get n square plus n minus 30 is equal to 0. Now again, this is a quadratic equation. Factorize it, you will get n plus 6, n minus 5 is equal to 0. So from here what you will get? From here you will get n is equal to minus 6 or n is equal to 5. Now since n was the number of elements in a set, it cannot be equal to minus 6. So the number of elements in your set is 5. So since n cannot be a non-negative integer, n should be a non-negative integer. So we have n is equal to 5. So the answer of this question is number of elements are 5. Option number A. So your next question, you are given alpha, beta, gamma are some 3 real numbers which satisfies this equation and this equation. So which satisfy these 2 equations which are equal to 0. So you have to tell the value of cos alpha minus beta. So this is from your trigonometry and you want value of cos alpha minus beta. So what we will do? The first equation is cos alpha plus cos beta plus cos gamma is equal to 0. So take cos gamma on right side. This is what you will get. From your second equation, do the same. You will get sin alpha plus sin beta is equal to minus sin gamma. Now do what? Square both the equations. Square this equation as well as this equation. So squaring both sides will give you what? When you square them and add them, this will give you cos alpha plus cos beta square plus sin alpha plus sin beta square, and this is equal to minus cos alpha square plus minus sin gamma square. So we did what? We squared this and added both the equation. Now we expand the terms. Apply x plus y whole square here. Apply x plus y whole square here. You will get cos square alpha plus cos square beta plus 2 cos alpha cos beta. Similarly for this you will get this expression, and this is equal to cos square gamma plus sin square gamma. Now we know this is what? Sin square theta plus cos square theta is 1. So sin square alpha cos square alpha will become 1. Cos square beta sin square beta will become 1. So these 4 expressions will become 1. So 1 plus 1 plus 2 times of cos alpha cos beta plus sin alpha sin beta, and this is also 1. So now do what? Just simple calculation. This is 2. Take it to the left. It will become minus 1. So 2 times of, and this is what? This is cos alpha minus beta. Remember the identity of cos alpha minus beta. So what is your cos alpha minus beta? Your cos alpha minus beta is nothing but cos alpha cos beta plus sin alpha sin beta. So that is what it is written. So this will become 2 cos alpha minus beta is equal to 1. So from here you will get cos alpha minus beta is equal to minus half. So this was just a manipulation and calculative question. So you have to do what? Just manipulate it, and your answer is option number A, which is minus half. This is a good question. What it says, consider this parallelogram as shown here, and you are given the ratio of AE upon AB is equal to CF upon CD. So you are given the ratio of AF upon AB and CF upon CD, which is equal to 1 by n for some positive integer n. N is some positive integer. So you are given length of AC as A. So the length of this side AC, complete side AC is A. You have to tell the length of XY. So we have to tell the length of this X and Y. So since ABCD is a parallelogram, we know AB will be equal to CD. ABCD is a parallelogram, AB will be equal to CD. Also given this relation AE upon AB is equal to 1 by n, we will have AE is equal to 1 by n times of AB. AE will be equal to 1 by n times of AB. And similarly by symmetry, your CF will be 1 by n times of CD. That is just from this relation. Now consider these two triangles. Now here you have to consider these two triangles AEX and CXD. Consider these two triangles. What you will see? You will see angle A will be equal to angle C, alternate interior angles. Angle X is equal to angle X, vertically opposite angle. So two angles are equal. So by asymmetry, these two triangles will be similar. So these two triangles will be similar. So what we will get? We will get ratio of sides to be equal. So AX upon CX. AX upon CX will be equal to AE upon CD. So the ratio of sides will be equal. So AX upon CX will be equal to AE upon CD. Now AE was half 1 by n times of AB. So 1 by n times of AB cancels out. AX upon CX is 1 by n. So from here I can write CX is equal to n times of AX. CX is nothing but your n times of AX. Now AX plus n times of AX. This is your AX. This is your AX. This is your AX plus what? CX. CX is your this length. AX plus CX will totally completely will make AC. So this will completely make your side AC. So AX plus CX is your n times of AX. So AX plus n times of AX will give you complete length A. Add them, you will get n plus 1. This will give you what? This will give you n plus 1 AX is equal to A. So from here directly you will apply and you will get AX is equal to A upon n plus 1. This is what it is written. AX is equal to A upon n plus 1. Now similarly, when you apply this in this triangle, when you apply this in triangle CFY, when you apply this in CFY and this big triangle AYB, now apply the same similarity in these two triangles, you will get what? You will similarly get CY is equal to A upon n plus 1. Similarly apply the same process, you will get CY is equal to A upon n plus 1. Now what will happen? This length AX is your length AX is A upon n plus 1. Your length CY is also A upon n plus 1. You wanted what? XY. What is XY? XY is AC minus AX minus CY. When you see the lengths, XY is AC minus CY minus AX. So this is the formula that we will use. XY is AC minus AX minus CY. So subtract these two values from length AC. So A minus A upon n plus 1 minus A upon n plus 1. When you subtract these two, your value of XY will come out to be, so here it is hidden, your value of AX will come out to be n minus 1 times of A upon n plus 1. So this is what you will get as the value of XY. So what is your correct option? Your option number C is the correct answer for this question. So this only needed you to identify the similarity of triangles. You could have approached this question using geometry as well, taking a coordinate of A and then finding the coordinates of B, C, D and other values as well as vector algebra. So you can approach this question from that point of view as well, but this was the easiest solution and approach that you can go for this question. Now your next question is from your sequence and series. What it says, A1, A2, A3 be a sequence. Now sum is defined, Sn is defined as A1 plus An, that is the sum formula, and you are given 2Sn is equal to n into C plus An. So you are given a relation for Sn for some real number C and for all n. Then you have to tell which of the following is true. Are these in AP, these in AP, this is in GP or this is in GP. So what we have? We have Sn. So you can see Sn is what? Your Sn is A1 plus dot 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 An. What will be your Sn minus 1? Sn minus 1 will be A1 plus dot 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 An minus 1. Now you subtract Sn from Sn minus 1. Sn minus 1. This will cancel out. All the terms will cancel out. You will be left with An. So this is a good relationship to find the term if your sum is given. An is equal to Sn minus 1. So this is what we used. Sn minus 1 is equal to An, and this will be true for n greater than or equal to 2. Because this is n minus 1. We cannot put n1, so this will become as 0. But 0 is not a term. So this is true for n greater than or equal to 2. Now just apply this. What is your Sn? Sn is your, we can divide this by 2. So it will become n into C plus An by 2. So n C plus An by 2 minus n minus 1. Put n minus 1 here. N minus 1 C plus An minus 1 upon 2. And that is equal to what? That is equal to your An. That is equal to your nth term An. Now just what? Do what? Just do basic maths calculation, take LCM and all. So you'll get NC plus NAN. Open this, minus n minus 1 into C minus n minus 1 into An minus 1, and this will become equal to 2 times of An. So this after simplification will give you C plus n minus 2 An will be equal to n minus 1 times of An minus 1. So this comes to the right, and when you solve these terms, your terms will cancel out and you will get C plus n minus 2 times of An. Now put the value for n is equal to 2. When you put n is equal to 2, this will give you what? C plus 0. 2 minus 2, 0. And 2 minus 1 is 1. And this will become A1. So for n is equal to 2, C plus 0 is equal to A1. So from here you will get your A1 as C. When you just put n2, your A1 will come out to be equal to C. So you just substitute C as A1. So you substitute C as A1. So this will be your relationship in An and An minus 1. So this will become your relationship in An and An minus 1. Now this is a linear recursive representation of an arithmetic progression. Why? Why? Because your C was what? C is now your A1. So what will be your sum? Your Sn will become n by 2 A1 plus An. And if you remember the formula for sum of n terms of an AP, so you can easily say this is what? This is the sum of n terms of an AP. We can write the sum of AP as n by 2 first term plus last term. So this is nothing but this becomes the sum formula for an arithmetic progression. So we will say what? We will say A1, A2, A3, all these terms are in AP. So your answer to this question is option number A. Now let us look at your next question. This is a very easy question, direct application from your binomial theorem, if you remember this particular identity. So what it says, you have to find the value of 2025 C1 plus 2 into 2025 C2 and so on. So you have to tell the value of this particular expression. Now we know the identity of binomial coefficient by binomial coefficient properties, R times of NCR. R times of NCR is equal to what? N times of n minus 1 CR minus 1. That is what the identity we used here. Because I can see these expressions as what? I can see these expressions as R times of NCR. R times of NCR. So this we will apply here. So this summation will be equal to this summation. This summation will be equal to this. So from R1 to n times of n minus 1, C R minus 1. So change R from 1 to 0. Take k equal to 0. So this will range from 0 to, instead of n, now it will become n minus 1. And R minus 1 is replaced with k. So what we did? We take R minus 1 as k. We took R minus 1 as k, or we can say we replaced R with k plus 1. This is what we replaced with. So R was starting from 1. When you put 1, k will start from 0. So for R is equal to 1, this implies k is equal to 0. So the sum will start from 0 and it was going till n. So this will become, and for n, this will become n minus 1 is equal to k. So sum will run from k is equal to 0 to n minus 1. And this is n minus 1 c k. Now remember, this is what? This is the sum of binomial coefficients. This is nothing but, this is your sum of binomial coefficients. So what is the sum of binomial coefficients? The sum of binomial coefficient is 2 to the power n. The sum of binomial coefficient is 2 to the power n. Now here your n is running till n minus 1. So we have this formula, right? Sum from k is equal to 0 to n ck. This is what 2 to the power n. Sum of all binomial coefficient is 2 to the power n. Now instead of n here it is n minus 1. So this will become 2 to the power n minus 1. So n into 2 to the power n minus 1. So what is your value of n? In your original question, value of n was 2025. So just substitute it. You will get 2025 into 2 to the power 2024. So all you needed to remember is this identity and sum of all binomial coefficients, which is 2 to the power n. And hence you will get the option, you will get your solution as 2025 into 2 to the power 2024, which is your option number D. Next is a locus problem, and it is a good question. If the locus of a point, this is the point given, such that the perpendicular distance from P to the line this. So you have this line, general line, which is 4y, 4x. So you have this general line 4x minus 3y plus 6 is equal to 0, and you have a point in the plane which is h comma k. So the perpendicular distance from this point to this line is twice the perpendicular distance from same point to the line x plus y minus 1 is equal to 0. So you have to just use the formula for perpendicular distance. The formula for perpendicular distance is mod of ax1 plus by1 plus c upon under root a square plus b square. So for this first line your points are h comma k. So it will become 4h minus 3k plus 6 upon under root 4 square plus minus 3 ka whole square. And this is given to be equal to twice the perpendicular distance from this line. So just apply the distance formula, you will get this relation between h and k, and this equation will be formed. So now just solve this. This will be 5, this will become root 2. Take 5 to the right side, it will become 10 by root 2. This will be mod, this will be mod. Now for solving mod equations, you take square on both the sides. You take square on both the sides. So when you take square, this will become 10 by root 2 square, and this will become square of this term. So this is 4h minus 3k plus 6 square. When you solve this term, it will be 100 by 2, which will become 50, and this is h plus k minus 1 whole square. So now we wanted what? In the question, it is given the locus is represented as this. The locus is represented in this way, and you only want value of a minus c. So you want just the coefficient of h square and you want the coefficient of k square. So we will not calculate and evaluate all the other coefficients. We will only focus on a and c. So you want coefficient of h square and k square. So when you expand this, coefficient of h square from here will be your coefficient of h square, coefficient from here it will be 16, and from here the coefficient of h square will be 50, and from here your h square coefficient will be 50. So that is what the coefficient you will get, 4 square. So you will get 4 square or 16 minus 50. So value of a will be 16 will be here, 50 will be here. Take it to the left and you subtract them. So you will get 60 minus 50. That will give you minus 34. So your value of A is what? Your value of A is minus 34. Similarly, your coefficient of k square. From here you will get 9, from here you will get 1 and then 50. So you will get 50. So 9 and 50. So you'll get 9 minus 50 and that is minus 41. And you want what? You want value of mod A minus C. So mod A minus 34 minus of 41. So when you solve this, you get mod 7 and mod 7 is nothing but 7. So your answer is 7, option number C. So you have to tell the value of mod A minus C, which is our option number C, value is 7. Now let us look at this next question. This is from your stars and bars method, from your permutation and combination. What it says, let n be the number of solution to this equation with x0, x1 and these are positive, or you can say non-negative integers. Not positive, these are non-negative integers. Then you have to tell n lies between which interval. So you have to tell the interval of n. So basically you have to calculate all the number of solutions and then you have to check in which interval it lies. So let k is equal to this term. Since 2 is multiplied with these 4 expressions, let k be equal to x1 plus x2 plus x3 plus x4. So now your equation reduces to x0 plus x5 plus 2k is equal to 6. Now we solve for different values of k. Now we solve this equation for different values of k. Now since these are non-negative entries, the value of k can also be non-negative only. So k can take what values? K can take 0, 1, 2 or 3. Because when you take k is equal to 3, this will become equal to 6 and 6 minus 6 will be 0 and then you cannot take further values of k. Because if you take 4, this will become what? This will become 8 and then when you take it to the right side, this will become 6 minus 8. So the expression will become negative, but you want only non-negative integral values. So these two values will not become non-negative integers. That's why k will run from 0 to 3 only. So this is the reason your k runs from 0 to 3. So now when k is equal to 0, that means, so k is equal to 0 means this implies x1 plus x2 plus x3 plus x4 is equal to 0. Now remember your stars and bars method. What it says, if we have this equation, this is equal to some value n and you have to tell the non-negative integral solutions. So your formula is what? Non-negative integral solution, number of non-negative integral solution. So if you have to tell the non-negative integral solution of this expression, your stars and method says the formula is n plus k minus 1 and k minus 1. So this is the formula for non-negative integral solution. So when you compute it here, your n is 0, k is 4. So 0 plus 4 minus 1 upon 4 minus 1. So this will be 3, 3 and you know 3c3 is what? 3c3 is 1. So you will get number of ways as 1 only. Your number of ways to solve this is 1. Now what will become when k is 0? This will give you x0 plus x5 is equal to 6. Now x0 plus x5 is equal to 6. Apply the same stars and bar method. Apply the same method. You will get what? 6 plus how many terms? 2 minus 1 upon 2 minus 1. So this will give you 7 C1, this is 7 factorial upon 1 factorial into 6 factorial, that is equal to 7. So from here your number of A's that I have written is equal to 7. So total will be 7 into 1, which is 7. Similarly for your next case, k is equal to 1. K is equal to 1 means, now k is equal to 1 implies x1 plus x2 plus x3 plus x4 is equal to 1. Apply the same stars and bar method formula. It will give you 1 plus 4 minus 1 upon 4 minus 1. So this is the combination formula. So this is 4c3 and value of your 4c3 is nothing but value of your 4c3 is 4. So this will give you 4 ways to solve this equation. So from here I get 4 ways. Now when k is 1, this will be 2, so this will become 4. So x0 plus x5 will be equal to 4. Apply the same stars and bar method formula, you will get this, and number of ways will become 5. Now 4 ways for this, 5 ways for this. Total number of ways will become 20, because you will get 4 different solutions for this, 5 for this. So independently when you see, you will get 20 different combinations. Then when k is equal to 2, apply the same formula for this relation, you will get 10 solutions. For this you will get now what? This will become 4, so x0 plus x5 will be equal to 2. Number of ways will become 3 for this case. So total 10 into 3, 30 cases. 30 from here. Similarly, when k is 3, you will get this formula for x1 plus x2 plus x3 plus x4. That will give you 20 solutions. Your x0 plus x5 will become 0. And again, this will have only one solution. x0 is equal to 0 and x5 is equal to 0. So from here you will get number of ways only 1. So total 20 into 1, 20. Now just add all of them. Add all the solutions. From here I have 7. From here I have 20, 30, 20. So 20 plus 30, 50, 70 plus 7, 77. So your total number of solutions are 77. Now 77 lies between which interval? 77 lies between 50 and 100. So your answer to this question is B option, which is 50 less than equal to n less than 100. So your next question says, if this equation and this have a common positive root, then you have to tell the value of b minus 2a mod. You have to tell the value of mod b minus 2a among these values. So your common positive root, it says it has a common positive root. So let alpha be your common positive root. Let us consider that common root to be alpha. Now since it is a common root, it must satisfy all the three equations. So this will be satisfied for first, for second and third. You get three different equations when alpha is your common positive root. Now here you see what? If you see carefully, here you get a plus b. And if I add these two equations, I'll get a term of a plus b times alpha. I'll get a same type of term just like this. So what I'll do addition of first and second equation. So add first and second, you get 2 alpha square plus a plus b alpha plus 27 is equal to 0. So from here you can put the value of, from here you will get a plus b alpha is equal to 36 minus alpha square. So just substitute this value, a plus b alpha, substitute as minus 36 minus alpha square. When you substitute it here, you will get 2 alpha square, and for this you will get this plus 27 is equal to 0. When you solve this particular expression, you will get alpha square minus 9 is equal to 0. So from here you will get two solution. Alpha is equal to plus minus 3. From here you will get three solution, alpha is equal to plus minus 3. Now since the question says it is a positive root, so we will consider the value of alpha to be 3 since it is a positive root. So now substitute alpha value 3 in your first equation and in your second equation and find the value of a and b. So when you substitute alpha as 3 in first and second equation, you will get what? You will get 9 plus 3a plus 12 is equal to 0. So from here you will get 3a is equal to minus 21. So your value of a comes out to be minus 7. And similarly, when you put it in the second equation, your value of b will come out to be minus 8. So your value of a and b are these, right? So now you have to just do what? You have to calculate the value of b minus 2a. So just do that, b minus 2a. So it came out to be 6, and when you take the mod, it will still be 6. So your answer to this question is. So let us look at your next question now, which is, let 1, xi2, xi3 and xin be the roots of this equation. So you are given these to be the roots of this equation for n greater than or equal to 3. So n is greater than or equal to 3. Then you have to tell the sum of these values. Now you can see these are written in 1 upon x minus xi format, right? This is something of the form 1 upon x minus xi2 plus 1 upon x minus xi3 and so on, right? You can see that where your value of x is 2. So what and how we can approach this question? Now since this is a polynomial, we can write this as x to the power n minus 1. Now it is given that these are the roots. It is given to us that these are the roots. So we can factorize this as x minus 1, x minus j2 till x minus jn. So these are the n roots. So we can factorize this as this. Now we can take the log on both the sides. Why? Because this is like the derivative of this term, right? So when we take the log, it will become 1 upon x minus 1 when you take the derivative. And it is easy to differentiate when you take the logarithm. So take natural logarithm on both the sides. This will become ln of x to the power n minus 1, and here your ln will expand like this by using the property of log in product. It opens as addition. So now when we differentiate both sides with respect to x, this becomes derivative of log is 1 upon x to the power n minus 1, and when you multiply with this, it will become what? Nx to the power into nx to the power n minus 1. So that is the derivative of the left hand side. When you differentiate this, this is 1 upon x minus 1. And what these terms are? These terms are sum from xi2 to xn. So I can represent this as like this: summation I running from 2 to n 1 upon x minus xi. Now you can see here the value of x is what? It is put as 2. So substitute x as 2 into the equation. You will get n2 to the power n minus 1 upon 2 to the power n minus 1 is equal to 1 upon 2 minus 1, which is 1 only, plus s. This is the required sum s. So we denoted it with s. So your s is this term minus 1. So when you solve this, when you take the LCM and solve this, you will get final answer as 1 plus n 2 to the power n minus 1 minus 2 to the power n upon 2 to the power n minus 1. So from here, which option can you see? So this corresponds to which option? This is your option number C. So your correct answer is option number C. 1 plus n into 2 to the power n minus 1 minus 2 to the power n upon 2 to the power, oh, it is 2 to the power n minus 1, right, in denominator. So it is not option number C. This is your option number B. 1 plus n 2 to the power n minus 1 minus 2 to the power n upon 2 to the power n minus 1. So all you needed to do is just factorize this, take log and differentiate. Next question. This is an interesting question. It says, call a 7-digit telephonic number D1, D2 till D7 memorable, which means it can be memorized easily if the prefix sequence, which means if D1, D2, D3 is exactly same as either D4, D5, D6 or D5, D6, D7. It means to say if your number D1, D2, D3 is either equal to this, or it says this is equal to this. So how we'll approach this? Then it says possibly both, right? Assuming that each di can take the value from 0 to 9. So the telephonic digit numbers can take value from 0 to 9. We have to tell the number of different memorable telephone numbers. So we want to take the telephone numbers memorable. So let S be the set of all 7-digit sequence di. So we have assumed let S be all possible 7-digit sequence of our di. We have considered A to be the case where this D1, D2, D3 is equal to D4, D5, D6, which means D1 will be equal to D4, D2 will be equal to D5, D3 has to be equal to D6. So ways to choose D1, D2 and D3. So you have 10 ways to choose D1. So D1 can be from 0, 1 till 9. So you have 10 ways to choose D1. Similarly, 10 ways to choose D2 and 10 ways to choose D3. So D1, D2, D3 can be chosen in 10 different ways. Now when you choose a D1 value, your D4 will be fixed. Similarly, D5 and D6 corresponding to D2 and D3. So you have 10 to the power 3 ways to choose this, and these get fixed. Now what about D7? D7 is also left, right? So D7 in this case has 10 choices. So your total number of choices are 1000 into 10, which becomes 10,000. So your A set, which was this case, gives you 10,000 choices. Similarly, consider the second case. where d1, d2, d3 will be equal to d5, d6 and d7. Similar to this case, d1, d2, d3 will have 10 to the power 3 choices. Now d5, d6, d6 are and d7 are fixed. So you are left to choose now d4. d4 now has 10 choices, and similarly this will also give you 10,000 choices. Now in this both of the cases we took some intersections which we counted twice. So let A intersection be the case where all these three are equal. So let this be the case where all these three values are equal. So when you will compare them, d1 will come out to be equal to d4 and d4 will be equal to d5. But the second case says d2 is equal to d5. Now d1, d5, d4 are equal and d2 and d5 are also equal. So this says d1, d4, d5, d2, d5, d6 and all these will be equal. When you compare all these three, you will get all numbers are equal to each other. So this particular case gives you all numbers are equal. So now you can choose only one of them, the other automatically gets fixed. Let's say if you choose d1 as 0, all others will be 0 as well. So how many choices we have? Just choose any one of them. There are such 10 numbers, all zeros, all ones until all 9999999. So in the intersection, how many elements you will get? You will get only 10 elements. Now we want total memorable numbers. For the total memorable numbers, set A, set B minus A intersection B, because in A intersection B we have something that we counted in both A and P. So add AB and subtract A intersection B. So your final answer will be 19,990. So your total memorable numbers are 19,990. So which is your option number A. Next, this is an interesting question, and these types of question are very familiar and very you can say very familiar and mostly asked like this kind of questions. So what we'll do in this is, let ABCD be a square with side length 2. So here given ABCD is a square, length of this square is side length is 2. A large circle is inscribed in the circle touching all the four sides. So it says a large circle is inscribed which touches all the four sides, which means if you draw a line from here center of circle to this square, the length of this will also be equal to 2 centimeter or 2 units, you can say whatever unit it has. Let's say it is 2 units only, right? So what would be the radius? The radius of this large circle will be equal to 1. So radius of large circle, so your radius of large circle is equal to 1. So from here I get the radius of big circle as 1. Now a small circle of radius r is placed in a corner such that it is tangent to the two sides. So it is tangent to this side of the square and this side of the square, and it is also externally tangent to the large circle. So it is also touching externally this larger circle, and we have to find the value of r. So you have to find the value of radius of this small circle. So we have to find the radius of this small circle. Let this is r, let this radius be r. So you have to find this value. So how you will approach this? Now the solutions. Let d be the corner and it be the origin. So let us consider this coordinate of d as 0, 0. Now since we have considered this as the origin, this becomes your x-axis and this becomes your y-axis, right? And since the length is 2 units, so I know this coordinate will be somewhere, this coordinate will be minus 2 comma 0, sorry 0 comma minus 2, this will be 2 comma 0 and this will be 2 comma, this will be 2 comma minus 2. I know the coordinates of all the square, right? But what would be the coordinate of the center of circle? What would be the coordinate of center of this circle? So I know this has radius 1. This has radius 1, which means on the x-axis, you will move what? you will move 1 unit. So you will move 1 unit on the x-axis, and on the negative y-axis, this is the negative y-axis, you will also move what? You will move 1 unit. So the center coordinates are -1 comma, 1 comma -1. So the large circle, let's say its center be O1 with side length, so the square is of side length 1, 2, radius of this circle is 1, its center is at 1 comma -1. So the way I told you, the center of this large circle will come out to be 1 comma -1. Now the small circle, which is radius r, since the circle is tangent to the axis. Now this circle is tangent to the x-axis, which is your x is equal to 0 and y is equal to 0. So it is tangent to this two axes. So its radius would be what? Its radius will be r comma minus r. So the center of this will become what? Since this distance you will move will be your r, this distance will be also r. So the center O2 of this circle will become your r comma minus r. Now I have coordinates of center of larger circle, I have coordinates of center of small circle, and I know since these two circles are touching each other externally, the distance between their center would be what? 1 plus r. Since this distance is what? 1, so the center distance of both the circles will be 1 plus r. So we use that formula. So 1 plus r would be equal to distance between their centers. Now first center is this, second is this. Apply the distance formula. So this will be r minus 1 whole square plus minus r minus minus 1 whole square is equal to 1 plus r. Since I know this distance is nothing but 1 plus r. So equate this, solve this, you will get this term. Now since I know r is less than 1, the small circle radius would be less than 1 because the radius of larger circle is 1. So this will be obviously less than 1. So I can take the square root term and this term outside the root as 1 plus r. So now this gives me the equation. When you solve this for r, you will get r is equal to root 2 minus 1 upon 2 root 2 plus 1. This will be the value that you will obtain. Now this is not in any of your options. So we'll do what? We will rationalize this. When you rationalize this, the final output you will get as 3 minus 2 root 2. So the radius of this circle is 3 minus 2 root 2, which is your option number A. So this was a good question from the exam point of view. Now let us look at your next question. So it says, suppose Px is a polynomial and it is given that mod of Px is less than equal to this value for all x greater than or equal to 0. So for all x which are non-zero and positive, which are 0 and positive, this inequality is satisfying. So we have to tell which of the following can be true among these. So now first thing to notice in this question, what are these terms? All these terms are what? You take the derivative and find its value at 1. If you do the derivative of Px, that will be P dash x, and that will be what? A1 plus 2a2x plus so on. So this terms looks like what? This is nothing but derivative at point 1. This is a1 plus 2a2 and so on. So this, all the terms are nothing but derivative at point 1. So we have to evaluate what? We have to evaluate the inequality for derivative at point 1. So this is what it says. Now evaluate it x is equal to 1. So first evaluate this polynomial inequality at x is equal to 1. So you will get what? P1, you put x is equal to 1 here. This will be 1 minus 1, 0. So mod of P1. So mod of P1 is equal to, this is less than or equal to mod 0. And we know modulus value is always greater than or equal to 0. So this directly implies P1 is nothing but P1 is equal to 0. So this directly implies your P1 is equal to 0. Now use the derivative definition. What does the derivative definition says? Since the value of P1 is 0 and consider this function as fx, and this function fx satisfy what? Its value at 1 is 0. We can use the definition of our derivative, which says px minus p1 upon x minus 1. So this is nothing but this is derivative at point 1. This will be less than equal to the function minus its value at 1, which is 0 upon x minus 1 modulus. So this inequality will be true because this is nothing but this value of fx at 1 is 0. Now take this limit as x tends to 1. So as limit x tends to 1, this will become what? This will become p dash at 1, and this will be derivative of this function at point 1. This will be nothing but this will be the derivative of this function e to the power x minus 1 at point 1. This is nothing but the definition of a derivative. What does the definition of a derivative says? Fx minus f1, which is some point, let's say fa, upon x minus a, and where limit this limit goes to, limit x goes to a. So this is the definition of a derivative which we applied on both the sides. So we will get p dash of 1 will be less than equal to, the derivative of this will be e to the power x minus 1, and this will be 0, and at point 1 we have to evaluate, so it will be e to the power 1 minus 1, so which is 1. So from here I get the inequality that mod of the derivative at 1 will be less than equal to 1. Now check the options. Your first option says it is greater than or equal to 2. Incorrect. Greater than equal to 5. Incorrect. D is also incorrect. Greater than equal to 3. Why? Because it says less than equal to 1. Now it can be. The question said what it can be. It does not say what it will be or it must be. It only says can be. So which means it can be greater than or equal to 1. And these two inequalities will only be satisfied at the point where this will be exactly equal to 1, which can be true. This can be equal to 1. So A, B, D are incorrect as they are all greater than or equal to 2. But the option C can only be true at exactly where? At exactly value is taking value 1. So the answer to this question, is your option number C. Now let us look at your next question. What it says? This says y square is equal to 4ax. So this is a parabola. This is your parabola. Y square is equal to, this is your parabola. Y square is equal to 4ax. This is your parabola. Y square is equal to 4ax, whose latest rectum is BC. So we have a latest rectum. What is a latest rectum? Latest rectum is a perpendicular line which is passing through the focus. So for this parabola, your focus will be at a comma 0, your vertex will be at 0 comma 0. So now it is giving that the latest rectum is BC. So let this be a latest rectum. So this is your latest rectum BC. Now next what it says, the line from B passing through the midpoint of line joining F and origin. So line from B passing through midpoint of line joining focus and origin. So passing through the midpoint of line joining focus and origin. This is your origin, this is your focus. So the line joining focus and origin, it has a midpoint, and the line from B. The line is going from B, your point B, and it passes through this midpoint, and it cuts the parabola at point A. So this point at which it cut the parabola again, this is said to be your point A. Now what it is asking, you have to tell the value of tan of ABC and ACB. So you have to tell the value of tangent of angle ABC and ACB. So your ABC is this is your angle ABC, and now ACB. So you have to join A to C. So this will be your angle ACB. So you have to tell the value of tangent at these two angles and add them. So what we will do, as I draw on the diagram, the focus of parabola will be at a comma 0, origin is 0 comma 0. The latest rectum endpoints are a comma 2a and a comma minus 2a. Since we know the latest rectum passes through latest rectum passes through focus, and this is a perpendicular line. So the coordinate of x will be a only. Now when you incorporate and put this value in your parabola equation, your value of y square will be equal to 4a square. So we will get y is equals to 2a and this will be minus 2a. So this is a comma minus 2a. So I know the coordinates of B and C as well. Now the line equation, we will form our line because we want the angles. So the midpoint is a by 2 comma 0, right? That would be the midpoint. Midpoint of 0 comma 0 and a comma 0. This will be a by 2 comma 0, which is obvious. Now slope of line BM. So we have 2 points a comma 2a, a by 2 comma 0. Slope can be formed. This is your, say, let's say midpoint M. We can find the slope for these two lines. The slope will be 2a minus 0 upon a minus a by 2. This will be your slope formula and this will come out to be equal to 4. So what will be the equation of this line BM? Equation of this line in slope form is y is equal to 4x minus a by 2. This is the equation of line BM. Y is equal to 4x minus a by 2, right? And when you will expand this, you will get y is equal to 4x minus 2a. You will get y is equal to 4x minus 2a. Now intersection point A, you have to find this line intersection with this A. A is what point? A is your point on the parabola. So put this value of x here. From here you will get x what? You will get x is equal to 4 plus y plus 2a upon 4. Substitute this value in the parabola. Why we substitute this? Because this point A lies on the parabola. So substitute it. From here you will get a quadratic of this form, and while solving this you will get y is equal to 2a and y is equal to minus a. So from here you will get two values of y, 2a and minus a. Now 2a is already this point. Y is 2a at this point B. This cannot be your point A. So your point A will have your y coordinate as minus a. So the y coordinate of this point is minus a. So the y coordinate of this point is minus a. So this point has coordinate minus a for y and for x. Now substitute y is equal to minus a in the parabola equation, you will get x is equal to a by 4. So you will get a by 4 for this point. So this is the coordinate of this point A. Now I have coordinate of A as well, B as well and C as well. Now we have coordinate of all these 3 points. Now calculating the tangent value, right? Tangent value, we have to calculate the value of tan of these, right? So now let us consider BC to be our reference line. So in general, we consider our x-axis to be a reference line for calculating the angles. So this is your x-axis, that is considered as a reference line for calculating the angles. This is your tan, this is your theta. So we calculate tan theta by 2-point slope form. So this is your reference line in general. Now let us consider this line as a reference line. This is in y-axis. So your value of slope for this is what? This is tan theta is equal to y2 minus y1 upon x2 minus x1 for this. So when you take y-axis as your reference line, this things get reversed. These gets reversed. So it will become xb minus xa upon yb minus ya. For angle ABC, if you take this as a reference line and you want this angle, so you will get what? You will get tan value, you will take coordinate of x above and y below. So you put xb minus xa upon yb minus ya, just substitute the values of xb, xa, yb and ya, you will get the value of tan of ABC as 1 by 4. Similarly for ACB, you will put xc minus xa upon yc minus ya, substitute the coordinates of A, B and C here and here, you will get this tangent value as 3 by 4. Now you have both the angle values, you have to just add them. So 1 by 4 plus 3 by 4 will give you final answer as 1. So the answer to this is D, which is option number D, and the value is 1. So this was a very good question. Now let us move on to your next question, which says, how many possible value of this pair, ordered pair, in which there are 4 values A, B, C, D. A, B, C, D are real numbers and such that ABC is equal to D, BCD is equal to A, CDA is equals to B, and DAB is equals to C. So we have to find these types of pair which satisfy these 4 conditions. So what you can do? You see 4 equations, right? Multiply all of them. When you multiply all of them, you will see A will come 3 times, B will come 3 times, C and D all will come 3 times. So this will become ABCD whole cube is equal to, this is D, ABC. So this will be equal to ABCD. When you multiply all the 4 equations, you will get this equation. Now you can consider P as ABCD. This is nothing but P cube is equal to P. This is nothing but P cube is equal to P. Now when you factorize this, you will get P minus 1, P plus 1 is equal to 0. Just factorize this. You can write this as P cube minus P is equal to 0. Factorize this and you will get this form. So P can take your value 0, 1 or minus 1. The value of P are 0, from here 1 and from here minus 1. So these are the values of P which are allowed. Now case 1, consider 3 cases when P is 0, when P is 1 and when P is minus 1. So case 1, when P is 0, if any variable is 0, so this P variable, this is 0, equation forces all variable to be 0. What it says, if your P is 0, which means A, B, C, D is equal to 0. This says A, B, C, D is equal to 0. So this implies A or B or C or D is equal to 0. Either one of them has to be 0. If the product is 0, any one of number is 0. Now if any one of them will be 0 and you put it in certain equation, let's say let A is equals to 0. Let us consider that when A is 0, what happens? From this equation, I'll get BCD as 0. From this equation, I'll get BCD is equals to 0. Right? Now, this is again an expression equal to 0. You have B or C or D will be 0. Now, when you put this again, any one of them, and you take that particular, equation for that thing, again you will get another variable will be 0. So this ultimately gives all the variable has to be 0. A, B, C, D will all be 0. So from here I'll get one solution. Now next case, when P is 1, so from ABC is equals to D. From this equation ABC is equals to D, multiply by D. Multiply D here and D here. So when I multiply D, I'll get ABCD is equals to D square. So this is nothing but 1. P is what? ABCD. This is 1. So 1 is equals to D square. Now when 1 is your equals to D square, and when you substitute in all the other equations, you will get A square, B square, C square, D square, all will be equal to 1. Now when square of a number is equal to 1, that number can be either 1 or minus 1. So ABCD has two choices each, 1 or minus 1. Also, the condition is that the product of ABCD should be 1. Now when 4 numbers are multiplied and their product is a positive number, so either all of them are positive or 2 of them are positive or none of them is positive. That can be the only case when all the 4 numbers multiplied gives you answer as a positive number. So 0, 1, negatives. So when you have no number as a negative, minus 1. So all are positive, 1, 1, 1, 1. This can be done only in one way. When 2 are negative, when 2 of them are negative, we have to choose 4 numbers out of which 2 are negative. So apply the combination formula. You will get 4C2, which is 6 ways. So in 6 ways, 2 of the numbers can be negative. And when all 4 are negative, then also you have only one single case when all are minus 1. So this gives you one way, this gives you 6, and this gives you 1. So total from this case is 8. So total solution from your case 2 is 8. Now last case, when P is minus 1. When you get P as minus 1, you will get D square is equal to minus 1. When you take this, you will get D square as minus 1. Now square of a number can never be equal to -1 in real numbers. In real numbers, square of a number can never be -1. So this gives me no solution for D. So how many total solutions we get? 8 from this case, 8 from here, 1 from here. So total solutions are 9. So your correct option is option number C. The next question. Now we are given set of complex numbers such that z plus 1 upon z is either purely real or purely imaginary. So this form of a number is either purely real or purely imaginary. So it is asking which of the following represent this condition in the argent plane. In the argent plane, this condition is represented by which of the following cases. So let z be a complex number of the form x plus iy. So when you put this value, when you solve this z plus 1 by z, this will be what? X plus iy plus 1 upon x plus iy. Now this is in denominator. Take rationalize this, multiply with x minus iy in the numerator and denominator for this term. So you will get x plus iy plus x minus iy upon x square plus y square. This is the form you will get. This is what it is written here, right? Now separate the real part and separate the imaginary part. So your real part will be x plus x upon x square plus y square. This will be your real part, iota y, and here will be minus y upon x square plus y square. So this becomes your real part, this becomes your imaginary part. So now let us consider this as u and v. Let this be u, let this be u, and this complete term be v. So let w, which is this, u plus iv. So the imaginary part is this and your real part is your u, which is this, right? So this is your imaginary part, this is your real part. First condition, when your imaginary part is 0. When it is purely real, that means your imaginary part is 0, which means v is equals to 0. So substitute and put this equal to 0. Solve. Either y will be equals to 0. From here I will get either y will be 0 or this expression will be 0. When you solve this expression to be equal to 0, what you will get? It says 1 upon 1 minus x square plus y square is equals to 0. This means 1 is equal to 1 upon x square plus y square, and this gives you x square plus y square is equals to 1. Now since z is x plus iy, I know my x square plus y square is nothing but mod of z, which is equals to 1. So this directly gives me x square plus y square is equals to 1, which is a unit circle. I know this is nothing but a unit circle. And what is this circle? This is mod z is equals to 1. Now second condition, when this is purely imaginary. So when this will be imaginary, this has to be equal to 0. Put this equals to 0. X will be taken common, this will be formed. So from here I'll get only x is equals to 0. Since this is a square of a number and 1 added to a positive number will never give you a value 0. So only x can be equals to 0, which gives you y-axis. So what are the solutions? So your solutions are x-axis union y-axis union the unit circle mod z is equals to 1. These are your solutions. So what your option 1 says? It is the union of x-axis and y-axis, but here note this term. It says including the origin. Origin means z is equals to 0, but in this expression you cannot put z as 0 because z is in denominator as well. So you cannot include the origin. So from here I'll exclude origin as well in my final solution. It is not this curve, this is the unit circle mod z is equals to 1. So mod z is equals to 1 is the perfect answer. Why? Because it includes all the points of the unit circle. Mod z is equals to 1. It includes all these points of mod z is equals to 1. Next question. It says if your quadratic equation px is equals to 0, with real coefficients. The coefficients are real and it says this is only purely imaginary roots. This equation has purely imaginary roots. Then we have to comment on this equation ppx. Basically, this is nothing but composition of your quadratic. So you have to comment on the roots of this quadratic. So let the purely imaginary roots of this equation be plus minus ki. Since it has purely imaginary roots, this will be of the form plus minus ki, where k will be some real number, where k is non-zero real number. Now since coefficients are real, the polynomial must be of this form only, because the roots are what? The roots are p is equals to ki or p is equals to minus ki. So your polynomial can be written as x plus ki and x minus ki. When you expand this, this will be x square plus k square. So this is the form of your polynomial, and since square of a number is always positive, so k square is a positive number. So this is how your polynomial will actually look like. Now you have to comment on the root of ppx. So write ppx, what will it be? Instead of x, you will always substitute px. So where it is x, you take px. So this will be px square plus k square is equals to 0. So take this k square on the right side. This is what you will get. And when you will take the square root, you will get px is equals to plus minus ki. So now you get an equation which says px should be equals to plus minus ki. Now your px was what? Your px was this. So substitute this, you will get x square is equals to minus k square plus minus ki. Now note that this square term x square has both real part as well as imaginary part. Also, since k was non-zero, none of the numbers, imaginary part or the real part, none of them will be equal to 0. So it has non-zero real part as well as non-zero imaginary part. So for x to be purely real, must have a positive real number. X square must be a positive real number, and for x to be purely imaginary, x square must be a negative real number, right? For it to be a purely imaginary, this should be a purely negative number, and for to be purely real, this should be a positive number. But since this is equal to minus k plus minus ki, it is a complex number with non-zero imaginary part. So the roots x will have both non-zero real and non-zero imaginary part. So this says it will have both non-zero real part and non-zero imaginary part. So that's why the answer is it is neither a purely real number nor a purely imaginary number. So the root is neither purely real nor purely imaginary. The next come up is, in an ellipse, ratio of area of rectangle formed by the endpoints of its lattice rectum. So let us consider your ellipses. Let us consider this is your ellipse. Let us consider this is your ellipse. This is your ellipse, and what it says? It says the ratio of area of rectangle formed by endpoints of its lattice rectums. So I know this is my standard ellipse. Its focus is at AE comma 0 and second focus is at minus AE comma 0. And the lattice rectums are, and these are your lattice rectum. So when you find the coordinates of your lattice rectum, your x coordinate here will be AE, here it will be AE, here it will be minus AE, and here it will be minus AE. Now for the y coordinate, just substitute the value of x this in your standard ellipse equation, and your standard ellipse equation for this is x square plus y square, this is equal to 1. This is your standard ellipse equation for this kind of a ellipse. Put the value of x as this, you will find the value of y. You will find the coordinate of this will be as b square by a. This will become minus b square by a. This will be b square by a. This will be minus b square by a. So these are the four coordinates, of the lattice rectum that is written here. So the rectangle is formed by the four endpoints plus minus a comma plus minus b square by a. So this is how your rectangle is formed. So your rectangle is formed by these coordinates. So this is your rectangle actually, right? So now area of rectangle. Length. What is the length? This is only moving in the x direction. So length is AE plus AE, 2AE. Breadth, height moving in y direction only. So this is b square a plus b square a. So your area of rectangle is 2AE into 2b square by a. When you solve this, you get 4e into b square. So this is your area of rectangle, and it says ratio with the area of ellipse. So I know area of ellipse is always what? Pi a b. So when you take the ratio, you will get 1 upon pi. And what is a of rectangle? 4EB square. So put 4EB square upon pi AB. B cancels out. So it is 4EB upon A equals to 1. So from here I'll get a relationship in BA and E. I'll get a relationship in BAE. E is what? Eccentricity of this ellipse. And I know the standard identity for the ellipse, which is b square by a square is equals to 1 minus a square. So put that value. So 1 upon 4e square will be equal to 1 minus e square. Solve this, you will find a 4-degree equation in your e square. You will get a 4-degree equation in terms of ellipse. When you solve this, you can take this as let e square is equals to t, and you can form a quadratic as well. But let us just solve it for e square directly using your quadratic formula. So this will give you e square value as this. Now here the trick used was you need to see this as a square of some perfect number, because the answers are not in double under root. The answer does not have any double under root values, because if I take a root here, if I take this, if I consider e square is 4 plus minus 2 root 3 upon 8, and I directly say my e will be plus minus under root 4 plus minus 2 root 3 upon 8. This is nowhere in your answer. So what you have to see, this numerator as a perfect square. So I can easily see 4 plus minus 2 root 3 is perfect square of root 3 plus minus 1 whole square, and 8 remains as it is. Now when you take the square root of this becomes square root of root 3 plus minus 1 square upon 8, and when the square and root cancels out, this will be root 3 plus minus 1 upon 2 root 2, which matches with your option number D. So here only you need to see this manipulation, how you will take this as a perfect square. So this, from the options also you can judge what perfect square will make this as root 3 plus 1 or 2 plus minus root 3 or 1 or singleton 1. So you can judge this thing from your options. Now next question is, you have to tell the number of non-congruent triangles. So what are non-congruent triangles? Which means those are not congruent. And what is the definition of congruent? Having all sides equal and all angles equal. So we have to tell non-congruent triangles with side length as ABC, where ABC belongs to these numbers, and so that there is a condition that this 3-digit number lies between 200 and 300. So there is a condition on this number which should be between 200 and 300. So for this number to be between 200 and 300, my value of a has to be equal to 2. Because if I take a as 1, it will be between 100 and 200. If I take a as 3, so 3 into 100 will be 300. So that number will exceed the value 300. So here, by this condition, my value of a is fixed, which is equals to 2. So for the number to be between 200 and 300, the 100 place digit, which should be equal to 2. So your 100 place digit is a, which has to be equal to 2. Now triangle has the property that sum of two sides should be greater than equal to the third side. So for this to form the triangle, it must satisfy what? The triangle inequality, or basically sum of side inequality. So b plus c should be greater than 2, b plus 2 should be greater than c, and c plus 2 should be greater than b. Now these two conditions, when you combine these two conditions, this one and this one, this says what? This actually says c minus b should be less than 2. This condition says c minus b should be less than 2, and the second one says b minus c should be less than 2. So this is your first condition and this is your second condition from these two. Now when you see them, you can take the mod, because if I take a negative sign, the inequality will change. So I can say that mod of this value should be less than 2. So I can say the mod of this value b minus c should be less than 2. Now since b and c are integers, why? Because b and c belongs to these value only, and it is saying mod of the value should be less than 2. So this directly means either b is equals to c or mod of b minus c is equals to 1. Right, that is correct. Why? Because mod of b minus c cannot exceed 2. So either when b is equals to c, it will become 0, and when mod of b minus c is 1, then only this inequality can be satisfied. So from here I get two cases when b is equals to c. The pairs can be 2, 2, 3, 3, 9, 9. So value of b and c can be 2, 2, 3, 3 until 9, 9, because the value it can take is from 1 to 9. And why did we not include the pair 1 comma 1? 1 comma 1 is not included because 1 plus 1, this inequality will not be satisfied. This inequality for the triangle will not be satisfied if I take 1 plus 1. This is not greater than 2. So this gives me 8 triangles. How many choices you have for BC? 1, 2 till 9, 9, right? So this has 8 choices. So from here I'll get 8 triangles. Now case 2, when your mod of b minus c is equals to 1. So non-congruent pairs. We want what? Non-congruent. So for non-congruent, I can either fix b or I can either fix c. So for this to be non-congruent, b and c are 1, 2, 2, 3, 3, 4 and till 8, 9. Why? Because if you take the other way around, if you say b is your, if you say this is 2, 1, 3, 2 and so on, this will form congruent triangles. Why? Because your triangle with this side and a is equals to 2 will be what? Your triangle with side 2, 1, 2 will be one triangle. This will be, let's say, your triangle 1. And when you take BC as this pair, so your triangle T2 will be 2, 2, 1. Now you can easily see all the three sides are equal. If you compare these two triangles, they are not non-congruent. They become congruent triangles. So I can take either B as 1 or C as 2 or B as 2 and C as 1. I only have one choice is to take these pairs. So from here I'll get these set of pairs, and this also gives me 8 triangles, and from here both the cases I'll get 8 plus 8. Total number of triangles that you have will be 16. So the correct answer is option number B. So your triangles will be total 16. Next question, let a and b a sequence of numbers satisfying this relation. So you are given a n is a sequence of numbers which satisfies this particular relation for all n, and you have to find the value of this limit. So this is a question from your limit and you have to find this value of the limit. So let us see how this actually relations open as. So when you manipulate this relation, you can write what? You can write 3 minus an plus 1 is equal to 18 upon 6 plus, you can write this as 18 upon 6 plus an, and take an to the right, an plus 1 to the right side. This will be 3 minus 18 upon 6 plus an. This is how your an plus 1 comes out. Now take the LCM. This is your final an. This is your final an plus 1 relation with an. Now this is asking what? This is saying 1 upon an types. The question says 1 upon an types. So let xn be 1 upon an. So that's why we considered xn as 1 upon an. Now when you take the reciprocal, this will become 1 upon an plus 1. This will become 6 plus an upon 3 an. Right? When you take the reciprocal of this is your equation. Now 1 upon an plus 1 is what? Xn plus 1. 1 upon an plus 1 from here will be xn plus 1. This is what? This when you solve this, you take an common with both. This will be 6 upon an plus an upon 3an. Now this becomes 2 upon an plus an cancels out, 1 upon 3. Now 1 upon an is what? 1 upon an is your xn. So this can be written as 2 into xn plus 1 by 3. So that is what it is written. So xn plus 1 comes out to be 2xn plus 1 by 3. Now you were given value at a0 is 3. So if your value of a0 is 3, your x0 value will be 1 by 3. If your value of a0 is 3, your value of x0 will be 1 by 3. So with x0 1 by 3, when you put it here and you try to find different terms, when you try to find next term, this is your general formula that will come out to be. So this is your general formula for xn that you can write. Now you can substitute this in this sum. So this Sn is what? This is summation from j0 to n, 1 upon aj. So 1 upon aj will be replaced by xj. So sum upon j to 0 to n xj, and take the sum here. This is 2 by 3 outside because it is a constant. 2 to the power j minus 1 by 3 is also constant. So you can sum and take it separately. Now this is what? This is a constant 2 by 3 and this will become a gp. This will become sum of gp. This term becomes sum of gp. Apply the formula of sum of gp, you will get 2 by 3, 2 to the power n plus 1 minus 1. So you will get for this particular value as 2 to the power n plus 1 minus 1. And since this is a constant, sum is running from 0 to n, so you just simply multiply n here. So you just simply multiply n here. So you just simply multiply n into n plus 1 by 2. So after solving and simplifying, this is what your sum will actually looks like. 2 to the power n plus 2 minus n minus 3 upon 3. So this is how your summation term will open as. Now you want to find the limit. 1 upon 2n plus 1. So divide it by 2 to the power n plus 2. So divide it by 2 to the power n plus 2. So separate them. When you separate them, 1 by 3 is outside. This becomes 1 minus n upon 2 to the power n plus 2 minus 3 upon 2 to the power n plus 2. Now I know this limit. The limit n goes to infinity of n upon 2 to the power n plus 2. So when you solve this, this will go to infinity upon infinity form. This will go to infinity by infinity form. Take the derivative. The derivative of numerator will be 1 and the derivative of denominator, when you take it with the log, the derivative of denominator, if you know that, let this be y. So take ln on both sides. Log y will be n plus 2 ln of 2. So this will give you y dash upon y is equals to n plus 2 ln of 2. So y dash will be what? Y into n plus 2 ln of 2. And when you take that limit to infinity, that will give you what? That will give you value in denominator as infinity. So this will give you 0. Right? So this value will become 0 and this value will again become 0, because when you take n to infinity, 1 upon infinity at positive will give you value 0. So the final answer of this limit is 1 by 3 only, which is multiplied with this 1. 1 minus 0 actually. So the value of limit is 1 by 3. Next, this is a good question from your relations. It says, let S be the set of all bijective functions from the set 1 to 3. So we have to take all bijective functions on this set to itself. So from this set to this. So we have to make functions from this set 1, 2, 3 to the set 1, 2, 3, and they should be all bijective functions. R1 and R2 are two relations defined on this set as R1 is such that f is related to g if f of g is equals to g of f. Basically the composition commutes. And second is relation is value of 1 is at equal to 1. So we have two functions. In this it says value at 1 are equal. Next, R is defined as R1 union R2. Another relation is defined which is R1 union R2, and we have to comment on these four options. First says it is an equivalent, second says reflexive and symmetric but not transitive, and the other option says reflexive transitive not symmetric, symmetric transitive not reflexive. So we have to take and comment on all the options and check all of them. So let's see. Let's analyze our relationship 1. So for reflexivity, f is related to f. You take any function f, f of f will always be equal to f of f. Reflexivity always holds. So f comma f is always an element of relation 1. Second, if f of f is equals to g of f, then g of f will be equal to f of g, clearly from the definition. So it is symmetric as well. Now transitivity. Let I be the identity function. What is the identity function? 1 is mapped to 1, 2 is mapped to 2, 3 is mapped to 3. So let I be your identity function. F be a function. So let f be a function. So here this is a printing mistake. So this is f of 1, f of 2, f of 3, and here it is actually h of 1, h of 2 and h of 3. So there was a printing mistake for f and h. So f be a function such that f1 is 1. So how this f1 looks like? So how this function f's look like? So this is your function f 1, 2, 3, 1, 2, 3, 1 goes to 1, 2 goes to 3, 3 goes to 2. This is your function f. And your function h is what? H is another function. This is your function h from 1 to 3 to the set 1 to 3, and it is defined as h of 1 is 3. So 1 is mapped to 3, 2 is mapped to 1 and 3 is mapped to 2. Then both of them are bijective. This function and this both are bijective functions, so they belong to this set. This is the set of all bijective functions, so they belong to this set S. Now what is FOI? When you composite any function with the identity function, it always returns me the function itself. So FOI will be what? FOI will be f. Similarly, IOF will be equal to f only. So these two are equal. Also IOH and HOI will be same. So f comma I is belonging to relation 1. I comma H is also belonging to relation 1. So I got two elements which are belonging to your relation number 1. But is f and h in this relation? So this says is f comma h belongs to your relation 1. So check it. For it to belong to relation 1, FOH should be equal to HOF. So what is your FOH at value 1? So let us calculate it at value 1. So H of 1 is 3. So this will be F of 3. And what is F3? F3 is your 2. And now next, if you calculate HOF at 1. So HOF at 1 is what? HOF at 1 is H of F1 is 1. So H1. And what is your H1? H1 is 3. Clearly 2 is not equal to 3. Clearly I can see 2 is not equal to 3. So FOH is not equal to HOF. Thus R1 is not a transitive relation. So my relation 1 is not transitive. Second relation, when you analyze that, it defines an equivalence relation because F1 will be equal to F1. Reflexivity holds. If F1 is G1 equal, G1 is equal to F1, symmetry. And if F1 is equal to G1 and G1 is equals to H1, then F and H has to be equal at that point. So this is an equivalence relation. Now you have to comment on the union. So for the union, Since both are reflexive, it is reflexive. Both are symmetric, it is also symmetric. But for transitivity, if you take this example only, it fails to be transitive. So the function f and g, f and h that are defined in relation 1, they fails to be transitive. So for these two functions only, when you apply it on the union, it fails to be transitive. So it is reflexive and symmetric, but it is not transitive. So correct option is option number B. So your answer to this is reflexive and symmetric, but not transitive. Next question is from your complex number. Let C denote the set of complex number and define A and B by. So these are the two sets that we are defining. Z comma W belongs to complex such that the modulus value are equal, and Z comma W belongs to complex such that their squares are equal. So we have to comment on these four options. Are A is equals to B, is a subset, B is a subset, or none of this. So we have to check if one is a subset of other or not. So see the second condition. It says Z square is equals to W square. So when you solve this, you get Z square minus W square is equals to 0. Form a quadratic, again factorize them. Z minus W, Z plus W is equals to 0. So from here I get either Z is equals to W. From here I get either Z will be equals to W or Z will be equals to minus W. These are the two cases that are possible. So when Z is equals to W, the mod value will be equal, and when Z is equals to minus W, then also their modulus value will be equal. So in both the cases, either this or this, the modulus values are always equal. So I can directly say if this is satisfied, their modulus values are equal. So in both the conditions, in both the cases, condition for set A, which says mod Z is equals to mod W is satisfied. So B is a clearly subset of A. You take any element in set B, it has to be in A, because when this condition is satisfied, it has to be that mod of Z is equals to mod of W. Now if it is equal or not, we have to check equality. So consider any element in A. Let us consider 1 comma I. Let us consider 1 comma I. We know mod of 1 and mod of I. The modulus value of 1 and I all both are same, which is equals to 1. So they belong to set A. But the pair, does this pair belongs to your set B or not? So check. What is 1 square? 1 square is 1. What is I square? I square is minus 1. And 1 is not equal to minus 1. 1 is not equal to minus 1. So this particular point, this particular element belongs to set A, but it does not belong to your set B. So clearly B is a subset of A. So from here I can say clearly that B is a subset of A. So your correct answer and correct option is option number C. Next come up, you are given any 5 points in this square. So how this square actually looks like? This is a square, it says x is from 0 to 1. So let us draw this square actually. Let us draw this square. So let's say this is your x-axis, this is your y-axis. Square says it is from 0 to 1. X values are from 0 to 1. So the value of x are from here till, let's say this is your point 1. Y value is also from 0 to 1. So y value is from 0 to 1. So when x is 1, y is 1, this point is also included, and this line is also included, and this line is also included. So this is how your square actually looks like. This is how you will draw this square. When you take x is equals to 0, you will get this axis. When you take x is equals to 1, you will get this axis. When you take y is equals to 0, you will get x-axis. When you take y is equals to 1, you will get this line y is equals to 1. So this is your square that is formed. And it says one of the following statement is true. Only one is true, and we have to tell which one is that statement. So this first option, so we have two approaches to do this question. Let me tell you your first approach, then we will see this actual solution. So let me tell you the first approach, then we will do this approach. It says the 5 points lie on the circle. First approach is discarding the options. The 5 points lie on a circle. Take 5 points like this. These are the 5 points inside this square, but they does not lie on any circle. These 5 points does not lie any circle. Next option says, so first is incorrect. At least one square can be formed using 4 of the 5 points. If I use any 4 points among this, I can only draw a line. I cannot form a square using these 5 points. So my option B is also incorrect. And what is your option number C? It says at least 3 of the 5 points are collinear. Now these are actually collinear, but how you can take 5 points? Let this is your square only. So you can take 5 points as this. You can form a pentagon. No 3 points will be collinear. No 3 points, at least 3. It says at least 3. No 3 points are collinear here. Maximum points that are collinear are 2. So this option is also incorrect. So by discarding, I can say only option number D is correct. So this was the approach when we did by discarding the options. Now let us look what actual solution says. So this actual solution says you draw this square and break it into 4 small squares, each with side length half. What it says, the length of this is 1. Break this into 4 squares. We have 4 different squares. Break this into 4 different squares with side length half. The length of this will be half because we are breaking it. This will be half only, right? Now calculating the maximum distance. If we place 5 points into 4 regions, so how many regions I form? I form 1, 2, 3, 4. I form 4 regions. If I put point in any of the one region, let's say this is 1 point, this is 1 point, this is 1 point, this is 1 point. I put any 4 points in the 4 regions A, B, C, D, let them be A, B, C, D. Now calculating the maximum distance. 1 point is still left. Where I'll put it? I'll put 1 point either in this one, in this or this. I only have 4 places to put another point. So either I'll put it in this one, or this one or this. I have only 4 choices. To fill 5 points. So 4 points are filled in different squares. So the 5th point will at least go in any one of them. It has to go in any one of them. So what is the maximum distance? If you look at this small square now, with side length half and side length half, the maximum distance between any 2 points in a square of side S is its diagonal. Now you take any 2 points inside this square, maximum distance is what? If you put a point here and another point here. So that is what? That is the diagonal of this square. So the maximum distance between any 2 points can be the diagonal of that square. So the length of diagonal, apply the Pythagoras theorem, find the length of the diagonal, that will come out to be 1 by root 2. So your length of diagonal will be 1 by root 2. Now if you put any point, any 2 point in this, let's say here or here, the length will be at max 1 by root 2. So it will never exceed 1 by root 2. So the length will never exceed 1 by root 2. If you put point anywhere else instead of the diagonal, this length will always be less than 1 by root 2, because the maximum length that 2 points can cover in a square of side 1 by 2 is the length of its diagonal, which is 1 by root 2. So since at least 2 points must fall within this square, so at least 2 points will fall in one square of this block of this side, distance between them cannot exceed 1 by root 2, and hence the distance between them cannot exceed 1 by root 2. So your correct option is D. So this was the approach, actual approach. This was by discarding the options. So let us look at your next question, which says the system of equation has a unique solution 1, 1, 1, and you have to tell which of the following option is correct. So you are given a system of equation and first verify if this is a unique solution or not. When you put it in this equation, you will get this is a unique solution. And since it says unique solution, which means now unique solution condition only says your determinant of the coefficient matrix cannot be 0. Now since the system has a solution, the determinant of coefficient matrix cannot be 0. So first condition is obviously false. So your option A is incorrect by the definition of existence of the solution. Now second, you have to look at the option B and C, and you need to know about the geometric description. So you need to know about the geometric representation. So for that, let's take geometric interpretation. Now three equations with a unique solution. Now these are your three equations, 1, 2, 3. Now when you have a three equations and you have a unique solution, then they represent non-parallel plane exactly intersecting at one point. So what this kind of situation is, you have three planes. So you have three planes and one is in your back side. Let's draw it like this. So they actually intersect at exactly one point. When a system of three equations has a unique solution, the planes intersect at exactly one point. And since they are intersecting at exactly one point, so any line, the line of intersection of the planes will also pass through that single point. Your point of intersection will also pass through all those lines, and hence all those lines will be concurrent, and hence all those lines will become concurrent. And since for this, option number C is the correct option. The equation represents three non-parallel planes and the lines of intersection of planes taken pairwise are concurrent. So whenever you have the line of intersection of planes, when you take them pairwise, the lines will always be concurrent, and hence option number C is correct. And when you want to see option number D, when you solve equation 1 and 2, the equation you will get will be minus y plus 7z is equals to 6. So it will not be this equation, it will be rather minus y plus 7z is equal to 6. So let us move on to your next question, which says if ABC are the roots of this polynomial, then the determinant of this matrix. So you have to tell the determinants of the matrix when you are given the roots of the polynomial equation, which are A, B, C. So if A, B, C are the roots, then by with the formula we know sum of roots will be 0, because this can be written as, this is nothing but x cube plus 0x square plus px plus q is equal to 0. Now since there is no coefficient of x square term, so a plus b plus c is equals to 0, and sum of roots, product of roots taken 2 at a time, is p, and product of all the roots will be minus q by the with the formula. Now solving the determinant. When you solve the determinant, just perform row operations, row 1 minus row 3, and in row 2 minus row 3. When you do that, you will get the determinant in simplified form as this. Now expanding along row 1, you expand this determinant along your row 1. This is the final expression that you will get, and when you use these properties, you will get this term as p, and this is minus q. So the final determinant will be p minus q. So which is the correct option? Your option number B. This was just an application of roots, with the formula, and just you have to determine what you have to just evaluate the determinant. Next, this is an question from your integration, and it is not asking you to evaluate this integral. Note that it is not asking you to evaluate this integral because we don't have a general formula. We can't apply any formula to evaluate this integral. So what we need to do? We just need to check where it lies. Where is the range there where it is lying? So on the interval from x 0 to 1, this is the integration from 0 to 1. So on this interval, this function, the function e to the power x square, it is continuous and strictly increasing. You can check it very easily. When you find its derivative, when you find the derivative of this function, it will be what? It will be e to the power x square into 2x. Now this complete term is always greater than 0 in this interval 0 to 1. You can exclude the point 0 as well, right? You can exclude the point 0 as well. So the derivative will always be greater than, or you can even say equal to 0. So the function is strictly increasing. So when that is happening, your minimum value will be at the lower point. So minimum value will be at 0, which is 1. Maximum value will be at the end point, which is 1. So maximum value is at 1, which is e. So this function fx, what is this? Your fx is strictly less than e and it is greater than 1. This is the inequality that will be formed. Now in integration, we know by the mean value theorem for integrals, when you take the integral here from 0 to 1 of 1 dx and from 0 to 1 of fx dx, and you take integral from 0 to 1 e dx, what you will get from here after solving this will be 1. This will be less than this complete integral. This is this part. So let it be like that. And now this, when you evaluate this, this will come out to be e. So your integral value lies in the interval 1 to e. So that is what it is written. Your integral value will always lie between 1 to e. So your option number C is the correct answer for this question. Now next question, it is also from integrals. Let a be a positive number, f and g are continuous functions on the interval 0 to a, and we are given a relation fx is f of minus ax and gx plus g of a minus x is equal to 3. And then you have to evaluate this integral and tell what this integral will be equal to. So solution. So using the property, you know this property, right? Integral from 0 to a fx dx is always equal to integral from 0 to a f of a minus x dx. We know this property. So applying this same property here, what we will get? We will get this integral as 0 to a f of a minus x g of a minus x dx, right? We can write this in terms of this. Now given, you are already given f of a minus x is fx. So replace that, replace fx here. So this becomes this. Now adding the original integral, you take this original integral and add this equation here. So you will get I plus I, 2i, and this integral plus this integral. So take fx common now. This becomes gx plus ga minus x. Now we know the value of this is given to us to be equal to 3. So just substitute this value as 3. So you will get 2i is equal to integral 0 to a 3 times of fx dx. Now 3 is a constant. So you can take it out. So your final integral will be 3 by 2 of integral 0 to a fx dx. And that is the solution to your answer. That is the solution to your this question. So your correct option is option number A. This is 3 by 2 times of 0 to a fx dx. This was a very simple question if you know this property and you know how to apply it. So let us move on to your next question. So you have to consider this particular polynomial and you have to take which of the following statement is correct. Which of the following statement is incorrect. False means which of the following statement is incorrect. Now note that many of the students mistake and don't read this. They don't read if you have to tell the false statement or correct statement. So remember this, always read the question carefully. So what it says, look at the option. Fx assumes every real value at least once. Mod fx is differentiable everyone. Fx has a local minimum in this interval. For x less than 0, fx always lie in the third quadrant. So let us look at the options one by one and evaluate it. So first option, it is a cubic polynomial, right? This is a cubic polynomial, and when you will take limit x tends to infinity, the x cube term will go to infinity. So limit x tends to infinity of your fx. This will go to what? This will go to infinity, and when you send this limit to minus infinity, your fx will move to minus infinity. So this is the limit for the cubic polynomial. So it will take every value. From minus infinity to infinity. It will not leave any value. So fx assumes every real value at least once. So at least once fx will take each and every value in your real line. So this is a correct option. Next, it says mod fx is differentiable everywhere. So you can factorize fx in this manner. You can see the roots of this polynomial are 1, 3 and 5. So this can be factorized in this form. So now when you have factorized this, so your polynomial would look like somewhat this. It would look like somewhat this. It has root at 1. So this will be at root at 1. Then it will go up and has root at 3. And then again it will go up like this. This would be the somewhat roughly graph of this polynomial. So this is your point 1. This is your point 3. Let's say this is your point 5. This is the rough graph of your polynomial, right? This is the rough graph of your cubic polynomial. Now it says mod fx. So when you take the mod, the negative terms becomes positive. The negative terms becomes positive. So this is what the graph of mod fx would look like. This and this, and then it will go like that. This is what the graph of your mod fx will be. Now you can see at this point it has a sharp turn, at this point it has a sharp turn, and at point 5 this graph has a sharp turn, and your function is not differentiable at those points where it has a sharp turn. So this function is not differentiable everywhere. So your incorrect option is option number B. So the solution and the question is done for us. But if you would like to check the other options, you can read this and you can see why the other options are true, right? So we are done with this question. Mod fx is differentiable everywhere, it says, but it is not differentiable at 1, 3 and 5. Next question. Now this is a good question, and it says this is a function defined over positive real number, and you have to tell which of the following statement is or are true. Now one thing to note down is this is or are. So this can be a multiple correct option solution as well. This can be a multiple correct question as well. And these types of questions used to come in your next exams, and so this question is brought up just to let you know that you can have a multiple correct question as well. And in such kind of question you need to evaluate all the options. So it says fx has a maximum at 1 by e. So let us evaluate all the options one by one. So this is your given function. Let it be y. Now you want to differentiate it. To check all these things, you need to differentiate, right? So take log on both sides, take ln on both sides. After differentiating, this is the term you will get. Now you have to find the roots. You have to find the roots for maxima, minima. So make it equal to 0. When this will be equal to 0, what you will get? This is x to the power 1 by x 1 minus ln x upon x square. So this expression is equal to 0. Now this term I know, this term is never equal to 0. Now you have to check why this term is never equal to 0. So this has to be equal to 0. So which implies 1 minus ln x upon x square is equal to 0. This implies 1 minus ln x is equal to 0 and ln x is equal to 1. And this is at x is equal to e. So your derivative is 0 at point e. That is what it is written here. Your derivative is 0 at point e. And at that point it attains its maxima. It attains the maxima at e, not at 1 by e. And you can easily evaluate why it will be a maxima. Let's say this is your point e. Now take any value less than e. You put any value less than e, ln of e will be, ln of any value less than e, ln of e is 1. For any value less than e, let's say ln of 2, this is less than 1. So here this will be positive, this will be positive. So function is increasing, and then after e the function will decrease. So here the derivative is positive, the derivative is negative. So derivative changes sign from positive to negative. So the function has the maxima at point e, not at 1 by e. So your option A is incorrect. Now look at option B. Look at option number B. It says fx, the maximum value of fx is among these is at 3. So it says the maximum value is at 3. Let us roughly draw this function. So when you roughly draw this function, it has a maxima at e, right? So let's say it starts from some point here. It won't be starting from 0. Let's say it starts from some 0.01. it increases first and then it decreases. It increases first and then it decreases, right? And this is the maximum at E. This has the maximum at E. So when you evaluate at 1, 2, 3, 4, 5, so at 1 it will be less than 2 because 1 will be here, 2 will be here, 3 will be here, 4 here and 5 somewhere here. So only you need to check the value at 2 and 3 because rest of the values will be less than values at 2 and 3. So let us evaluate it at 2 and 3. So since E is approximately 2.718, we check F2 versus F3. That's why we only check F2 versus F3. So when you evaluate 2 to the power 1 by 2 and 3 to the power 1 by 3, you can take 6 power on both the sides. You will get 2 to the power 3 is less than 3 to the power 2, which is 8 is less than 9. So F3 is the maximum among integers. So among all these, F3 is the maximum value. So this option is correct. It says it has maximum at F3, which is a correct answer. Now the minimum among all these is less than 1. It says the minimum value among all these values is always less than 1. So this is a false statement. Why? Because you can simply see f of 1. Your value of f at 1 will be 1 to the power 1 by 1, which is 1. But it says minimum is less than 1. But the value is always greater than 1. And at E it has the maximum. And we also know the limit of this function, this limit goes to 1 as x goes to infinity. So the function never drops below 1. So this function will never drop below the value 1 for any x greater than or equal to 1. So the minimum value among this is not less than 1. It is always greater than or equal to 1. So option C is incorrect. Now the fourth option, e to the power pi is greater than pi to the power e. So this is true. Since fe is the absolute maximum, the value at e is maximum. So fe will be greater than f of pi because pi is greater than e. So fe will be greater than f of pi, which means e to the power 1 by e will be greater than pi to the power 1 by pi. Now take power pi e on both the sides. Multiply with the power e to the power 1 by e and take power e pi on both the sides. Here e will cancel out. This becomes e to the power pi and this becomes pi to the power e. So e to the power pi is greater than pi to the power e. So if you have to check just this condition also in some question, or it is asked to check just this thing, you need to consider this function and you have to do this particular calculation. So this is also a good question, just if they ask what the inequality will be true. So you have to consider this function. So this is also a correct statement. So your correct options are B and D. Your correct solution and options are B and D. Now the next question, in this also you have to tell about the maxima, minima. You have to comment on the maxima and minima only. So for that again we need to take derivative. Now this is a variable in x. So we take the first derivative using the Leibniz rule. So take the derivative using your Leibniz rule. So your f dash x will be what? Derivative of this, which will be x e to the power minus x. When you take the derivative, it will be x e to the power minus x. Now you need to find what? Critical points. Why? Because we want maxima, minima. So set this equal to 0. When you set this equal to 0, again I know my e to the power minus x is never equal to 0. This is true. E to the power minus x will never be equal to 0. So x has to be equal to 0, and that is the condition that is written here. Now by the first derivative test, for x less than 0, since your critical point is 0, so value to the left of 0. For x less than 0, check the derivative. This is always positive, negative. So derivative is negative here and derivative is positive here. So derivative first decreases and then it increases. So this is the graph roughly that will look like. So it will have a minima at this point. So since this is the case, derivative changes sign from negative to positive. Function has a local minimum at x is equal to 0. So we got to know that this function has a minima at x is equal to 0. Now we need to comment on maxima as well. So you see, as x goes to infinity, when you take x approaches to infinity, the function integral will go to value 1. When you check this at infinity limit, it will go to 1, and as you take it to minus infinity, the function will blow to minus infinity. So it has no maxima value. It has no maximum, but it has a minimum which is at x is equal to 0. So function has a minimum but not a maximum. So your correct option is option A. Next, now this is a question from your vector algebra. What it says, A and B be two non-collinear vectors. So A and B are two vectors which are not collinear, and it is given they are unit vectors. This means they are unit vectors, and U is given in this particular manner, and you have to tell what this is not equal to. Now remember and clearly see here also it says not equal to. So you don't have to miss any word in the question. Note that thing very clearly. So you have to tell it will be not equal to. So whenever it says not equal to, you have to evaluate all the 4 options. You don't have any choice. You have to evaluate all the 4 options. So since these are unit vectors and this expression is this, let theta be the angle between A and B. Let us consider the angle between your vector A and B vector is theta. Now first simplify this expression. What is your expression? Under root of u vector dot a vector, the dot product. So take the dot product of this vector with A. What you will get? What you will get when you take the dot product? It will be A vector minus A vector into B vector, and this is B vector. So you take the dot product with A vector. Dot product can be distributed over subtraction. So this will be A dot A minus. Now this is nothing but a scalar. The dot product of two vector is always a scalar value. So this is just a value. So let it be like that. A vector dot B vector, and this will become B vector dot A vector. This is what u dot A will look like. This is what your u dot A will look like. Now this is nothing but this is mod A square minus this is A dot B, and A dot B is equal to B dot A. We know A dot B is equal to B dot A. So we can write this as A dot B whole square. So mod of A square, mod A I know it is 1, so it will become 1, right? Now this is A dot B square. So what is your A dot B? A dot B is mod A mod B cos theta, and this will be whole square. So this will become 1 into 1, and this will become cos square theta. So this finally becomes 1 minus cos square theta. Now this is 1 minus cos square theta, and we know the identity from trigonometry, this is equal to sin square theta, and we need to evaluate the root value. So under root of this will be sin theta. So under root of this expression will be sin theta. Now you have to evaluate the particular options. You take A into A cross B. A cross B magnitude. What is A cross B? What is your magnitude of A cross B? That is nothing but A vector into B vector magnitude, and this is sin theta. This is what the magnitude will open as, right? So this is magnitude of A vector is 1. So 1 1 sin theta. Now this is equal to sin theta. So this is equal to root of u vector dot A vector. Check second, that says mod, that says magnitude of u vector. So what is the magnitude of u vector square? That is u dot u. When you evaluate the u dot u, you will find it to be equal to 1 minus cos square theta, which is nothing against sin square theta. And since this is magnitude u square, you take under root on both sides, you will again get it equal to sin theta. And similarly, when you evaluate option number D, it is u cross B vector ka magnitude. It is magnitude of u cross B vector. So when you will evaluate that, you first evaluate u dot B. When you evaluate u dot B, you will get it to be equal to 0. Now since the dot product of two vector is 0, which means the two vectors are perpendicular to each other. So this implies u is perpendicular to vector B. Now magnitude is magnitude of u, magnitude of B, and the angle between them. Now since we evaluated that u is perpendicular to B vector, the angle will be 90 degree, or you can directly say sin theta value will be 1. So this is nothing but u magnitude and B magnitude. Now we know magnitude of u is what? We know magnitude of u is sine theta. We evaluated magnitude of u as sine theta in the option number B. And magnitude of B vector is what? That is simply 1. So this also comes out to be equal to sine theta. So your remaining option is option number A. And when you will evaluate it, you can check and you can read this. It will come out to be equal to 1 by 2 sine 2 theta. It will not be equal to sine theta, which is the simplified expression of this. So this is the final answer to your question. Next, again from your vector algebra. Suppose A, B, C are 3 vectors and length is given. What does it mean by length? By length, it simply means their magnitude. So length of vector and magnitude is the same thing. Okay, so such that this expression is valid. So you have to tell the angle between A vector and C vector. So this is what? This is A cross C. So this is a vector triple product. So this is a vector triple product. And we use this identity for vector triple product and we apply it here on this. It will be opening as A dot C into A vector minus A dot A vector into C vector plus B vector is equal to 0, because this is expression is given equal to 0 vector. Now A dot C, we have to tell the angle between A and C. So let us assume theta is the angle between vector A and C. So A dot C will open as A magnitude of C into cos theta. So what will be your A vector dot C vector? That is A vector, C vector and cos theta. Now it is given that length of A and C is 1. It is given to us length of A and C is 1. So this is 1 into cos theta. So this will be nothing but cos theta. So A dot C is cos theta into A vector. Now A dot A is magnitude of A square, which is nothing but 1 only. So 1 square into C vector plus B vector, right? So this expression, when you simplify and see, B vector will be what? C vector minus cos theta times of A vector. So your B vector will be C vector minus cos theta times of A vector. So this we have find an expression for vector B. Now square both sides. Why we square it? Because we know the length of vector B. Now if we square on both the sides, squaring both sides or take the dot product, we know we will get mod B square is equal to magnitude of C minus cos theta mod whole square. So magnitude of B square is equals to, apply the property A minus B whole square. So this will open like this. This will open like mod C square plus cos square theta magnitude of A square minus 2 cos theta C vector into A vector. Now I know the length of this is 1 by 2. So put the values for magnitude C, put values of magnitude of A, and A dot C is nothing but just your cos theta. When you solve this, when you simplify this, your cos square theta will be 1 by 4. Your cos square theta will be equal to this expression. So from here we get cos square theta is 3 by 4. So this is what this simplification gives. Then your cos square theta will come out to be equal to 3 by 4. So from here take the square root. Your cos theta will be root 3 by 2. And why we take only the positive value? This must be a question since you are preparing for your exams now. So you must be clear with this concept. We take only the positive value because the angle is acute. The question asked only the acute angle. So we take only the positive value. And we know cos theta is root 3 by 2 at what angle? It is value of root 3 by 2 at angle 30 degree. So the answer of this question is 30 degree. So the option is option number B. Now your next question, it says a fair coin is repeatedly tossed. So a coin is tossed repeatedly. It is repeatedly tossing a coin. X is an event that we get at least 2 head in 4 tosses. So X is given to be an event of at least 2 head in 4 tosses. And Y is the event that at least 3 heads in 6 tosses. So you have to tell which is the true statement. X is more likely than event Y is more likely than event X. Both are equal, or given data is insufficient to draw any conclusion. So what this means? This means you have to tell if probability of your X is greater than probability Y. This means it says probability of X is less than probability of Y. That is how you will read this statement as. X is more likely event than Y, which means the probability of occurrence of X, the probability that X will occur is more than probability that Y will occur. And equally likely means probability of X is equal to probability of Y. And the fourth is the given data is insufficient, which means you cannot draw any conclusion about all these things. So let us look at this step by step. Let us see at event X. It says at least 2 head in 4 tosses. So total outcomes, when you toss 4 times, when you toss a coin 4 times, your total number of outcomes are 2 to the power 4, which is 16. Now we want at least 2 heads. At least 2 head means 2, 3, 4, 2, 3, 4 heads, right? We are tossing it 4 times. So you want at least 2, 3 or 4. That is it means. So we can take the complement and find that. Complement is 0 head or 1 head. So let us evaluate this. This is easy to evaluate. So 0 head is all the tails. It has only one way. 1 head. What is the way to get 1 head? Head, tail, 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 head, tail, 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 head, tail, 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 head. So there are 4 ways to get only 1 head. So rest of the cases lie in this condition. So these are the 2 cases for 0 and 1 head. So total unwanted outcomes. These are our wanted outcomes. So these becomes unwanted outcomes. So total unwanted are 5. Total unwanted are 5. So our wanted will become what? 16 minus 5. Wanted outcomes will be 16 minus 5. So 16 minus 5 upon 16. So the answer for this probability of X is 11 by 16. Now let us read at your probability of the event Y. So it says at least 3 head in 6 tosses. So total outcomes in 6 tosses will be 2 to the power 6, which is 64. Now by symmetry in a fair coin distribution, probability of getting more heads than the mean equal the probability of getting fewer heads than the mean. So what this means? This means in a fair coin, you are tossing 6 times. Now either head will come or either tail will come. So the mean of getting head is 3. So your mean of getting head will be 3. And you want 3 only, you want at least 3. So whenever the mean is 3, probability of less than the mean and greater than the mean will always be equal. So that is what is true in the symmetric coin distribution case. So probability of getting more heads than the mean. So your mean is 3. So let k be the event. So k greater than 3 equal to probability of getting fewer heads than the mean, which is k less than 3. So let p of k greater than 3 is equal to p of k less than 3. Right? So these two probabilities will be equal and let it be equal to value A. And we also know sum of all probability in an event, in an experiment is always equal to 1. So probability that head will be less than 3 plus probability that it will be exactly equal to 3 heads plus it is greater than 3 heads. All the possible outcomes are covered in these 3 cases. So it will always be equal to 1. Now this is A, this is A. So 2A plus probability of k equal to 3 is always equal to 1. So from here you will get value of A as 1 minus probability at k is equals to 3 upon 2. So this is a simplified version. Now what it is asking? It asks at least 3 heads. So what you want? You want probability that k is greater than or equal to 3. So I can open this as P k is equal to 3 plus probability k is greater than 3. This can be simply opened like this. So this is what it is written. We want at least 3 heads. So probability of event Y is probability that it is exactly 3 plus probability it is greater than 3, which we assume to be equal to A. So Pk is equals to 3 plus A. Now probability of event Y will be k at 3. Put it like that. We solve value of A in terms of k is equals to 3. So put that expression here. So when you simplify this, you will get this term. Now what it says? This says probability of exactly 3 heads. This is nothing but this is probability of exactly 3 hits. So we want this probability of exactly 3 hits. Now you are tossing it how many times? You are tossing it 6 times. Tossing it 6 times and you want 3 combinations of hits. So this is a simple combination formula, getting 3 heads out of 6 outcomes. So 6C3, that will come out to be equal to 20. So your favorable number of ways to get exactly 3 hits. Number of ways to get exactly 3 heads from combination, it will be 6C3. That value is coming out to be equal to 20. So just substitute this value here. So you want probability at k is equal to 3. So your favorable outcome is 20. Your favorable outcome is 20 and your total number of outcomes were 64. So your probability that k is exactly equal to 3 is 20 by 64. So just put that value, evaluate this expression, it will be 21 by 32. Now just you have to check which is greater, less or equal. So just compare this value and this value. P of x, you can multiply it by 2, in numerator denominator it will be 22 by 32. So when you evaluate this and compare, so you will get Px is, this gives Px is greater than Py. So x is the event that is more likely to happen than event y. So x is the event that is more likely to happen than event y. So your correct option is option number A. Next, again a probability question. It says if a teacher assigns homework on nth day, probability that she will assign homework on the next n plus 1th day, which means in the today if she is assigning homework, then next day if she will assign the homework or not is 1 by 3. And if she does not assign homework on the nth day, which means if she does not assign homework today, then if she will assign it tomorrow or not will be 1 by 3. And if she does not assign that, if she does not assign today homework, then if she will assign tomorrow is the probability of happening, that is 2 by 3. Now if she assigned homework on Monday, so it is given to us, we are given that the teacher assigned homework on Monday. So we have to tell whether she will assign homework on Thursday or not. What will be the probability of that scenario? What will be the probability if the teacher will assign homework on Thursday or not? So let Hn be the event that homework is assigned on day n. So we have considered Hn to be the event that homework is assigned on the nth day, and let the probability be Pn. Let the probability be Pn that homework is assigned on the nth day. So we are given the initial state. We are given that on Monday she is assigning the homework. Now when she has assigned the homework, so the probability that homework is assigned on day 1, which is Monday. So for n is equal to 1 on Monday, she has assigned already the homework. So the probability will be 1. The probability of homework assigning is 1 on Monday because we actually know she assigned it. So now using the law of total probability, total probability, n plus 1th day. If she will assign it on n plus 1th day, we can write in terms of total probability. She assigns homework on nth day and she will assign on n plus 1th day into probability of assigning homework on nth day. And second case is does not assigning and assigning on the n plus 1th day. Multiply with probability of assigning homework on the not assigning homework on the nth day. So this is by the law of total probability. Now just substitute the values. This is given to us in question. This is given to us that probability of Hn plus 1 given that Hn will happen. Right. This is given to us in question in the language terms that the probability she will assign homework on n plus 1th day when she has already assigned on nth day. So given on nth day she will assign on n plus 1th day, it is given to be equal to 1 by 3. And similarly, she will assign on n plus 1th day given she does not assign. So this is the complement that she does not assign on nth day. This is given to us to be equal to 2 by 3. So just substitute these values and probability of Hn complement will be 1 minus P. If you are considering this as Pn, so the complement probability will be 1 minus Pn. So you get this relationship. you get this relationship of probability of assigning homework on n plus 1th day in terms of nth day. So now evaluate at Tuesday, Wednesday and Thursday. This is a simple calculation step that you will do on your own, I hope and suppose. So at 2, at 3 and at 4. Just evaluate it. So on Thursday, the probability will be 13 by 27. So your correct option to this solution, so your correct option to this question is 13 by 27. Next, this is an ODE equation and you are given a second degree ODE equation. So sometime next actually gives you a second order ODE equation. So how to solve this? When you are given a second order ODE differential equation, consider y double dash equal to m square, right? If, let me tell you in general only, if you are given an equation like this, if you are given a second degree equation like this, a times of y double dash plus b times of y dash plus c times of y is equal to 0. If you are given a general second order ODE differential equation in this format, so consider this as m square, this as m and this as simply 1. So this equation will become am square plus bm plus c is equal to 0. Now just apply the quadratic formula. This is a quadratic equation. Apply that formula and find the value of m. Find the value of m, right? So this is how you will approach second order equations. So in this it is given to us y double dash minus y is equals to 0. So instead of y double dash, we replace it with m square and instead of y we take 1. So this is called as characteristic equation. So your characteristic equation become m square minus 1 is equal to 0. So which gives you two values of m, which are m is equal to 1 and m is equals to minus 1. So when you solve this quadratic, you will get value of m as 1 and minus 1. Now the general solution of this is given by when you have value of m as 1 and minus 1. So let's say after solving this, you get values as m1 and m2. So your general solution will be some constant times of e to the power m1x plus c2 times of e to the power m2x. This is the general solution that you will get when you solve this quadratic and you get two values m1 and m2. So this gives you solution c1 e to the power x because your m1 value is 1 and c2 e to the power minus x because your m2 second value is minus 1. So this is your general solution to this. ODE equation. Now c1, c2 are any constant which are belonging to real numbers. c1, c2 can be any real constants. So now we have to check the four options. It says a non-zero decreasing solution exists. So we can take any value of c1, c2, right? So setting c1 as 0, you can take c1 to be 0, take c2 as 1. What will your function become? It will be e to the power minus x. Your yx will become e to the power minus x. Now since the derivative of this is minus e to the power minus x, which is always less than 0. So by first derivative test, I can clearly say that this is a non-zero strictly decreasing solution. So this solution that I formed here is a strictly decreasing non-zero solution. So your option number A is a correct option. And you can simply check all the other options very easily. It says a non-zero periodic solution. Now e to the power x is not a periodic function. E to the power x is not periodic. So we will not get a periodic solution. Next option, a unique solution. But if you change values of c1 and c2, there are infinite values of c1 and c2. So there is no unique solution. And it says two distinct solution. Again, we can take any value of c1, c2. There are infinite choices. So there will be infinite solutions. Next come up. So this is the Signum function. That is the definition of your Signum function, SGN. Now f is given to be a function defined by fx is equal to this x minus root 5 Signum function, Signum of x square minus 5. Then you have to tell the number of discontinuities of this function. So you have to tell how many points at how many points this function will be discontinuous at. And the options are 0, 1, 2 and 3. So let us see how this function will actually look like. Let us see how this function will actually look like. So this is what? This is your signum x square minus 5. Now we know signum changes its definition when it is equal to 0. When this x is 0, signum changes its definition. So check where this x square minus 5 is equal to 0. So this will give me x plus root 5, x minus root 5 is equal to 0. So at 2 points, at x is equal to root 5 and at x is equals to minus root 5, signum function, the expression is 0. So the definition of signum will become what? This will become 1 when x square minus 5 is greater than 0. It is becoming 0 at x is equals to root 5 and minus root 5, and it is taking negative value when x square minus 5 is less than 0. Now by wavy curve method and general inequalities, you know what will be the solution of this in interval representation. So my function can be broken down like this. This would be x minus root 5, x minus root 5. When signum is 1, it is 1 when this is true, and this is true in this particular interval. You can check this is true in this particular interval. So the value is 1. It is 0, the signum is 0 when x is minus root 5 and root 5. So this complete expression will become 0. And it is negative 1, so we'll multiply it with negative 1 when this is between minus root 5 to root 5. Now we need to check and analyze the continuity of this piecewise function. Now we always check the continuity of piecewise functions at the points where it changes its definition. So it is changing its definition at minus root 5 and root 5. So we will check the continuity at this critical transition points where the definition of function changes. So at minus root 5 and root 5. Let us see first at minus root 5. So left hand limit at minus root 5. The function to the left of minus root 5 will come from this particular expression. So when you check the limit of minus root 5 from the left side, it will take this value and you will get minus 2 root 5. Right hand limit will come out to be 2 root 5. Right hand limit will be evaluated from this expression. So when you check it, it will be 2 root 5. Now since left hand limit and right hand limit are not equal, function is not continuous. It is discontinuous at minus root 5. Similarly, check it at root 5. Similarly, we will check it at root 5. Now the left hand limit at root 5 from the negative side. So the function will take value from here to the left side of root 5. So it will be minus x minus root 5. That is what the function is taking its value from when it is approaching from the left side. So it will be 0. Right hand side, for right hand side, the function will take its expression from here, x minus root 5. So it will also come out to be equal to 0. Now function value at root 5 is also 0. Now all the three conditions are satisfied. So function is continuous at root 5. So function is continuous at root 5, but it is not continuous at minus root 5. So total number of points of discontinuity is only 1. There are no 2 points of discontinuity. There is only 1 point of discontinuity, which is x is equal to minus root 5. Now for this, we have to tell the set of all real numbers for which this function is strictly increasing. Again, this is a derivative and maxima minima application. So this is defined for 0 to 2 pi. So find its derivative. For strictly increasing, the derivative should be positive. That is the condition for strictly increasing. Derivative should be greater than 0. Find the derivative. Find the derivative of this function. It will come out to be this. You can simply evaluate it. It will come out to be this. For this to be greater than 0, we need to evaluate the sign of this term. For this to be greater than 0, we want this complete term to be greater than 0. So we have two cases, right? When both are positive and when both are negative. So when both are positive, which means cos x is also positive, 1 minus 2 sin x is also positive. From first condition, this is from second condition. And the values of x for these two conditions to satisfy is x should range from 0 to pi by 6 and 3 pi by 2 to 2 pi. Similarly, from your case 2, you will get this condition and this will be your value of x. This will be your interval for x. Now, combine both the cases, this will be your final answer. This is one approach. Second approach, let f dash x is equal to 0. Second approach is take derivative to be equal to 0. That will give you either cos x is 0 or 1 minus 2 sin x, or this will give you 1 minus 2 sin x is equal to 0. Find the critical points. So this will give you x is equal to pi by 2 and 3 pi by 2. So 2 points from here. We get 2 points from here, and this will give you sin x. This will give you sin x is equal to 1 by 2. So when sin x is equal to 1 by 2, your values of x are, when your sin x is equal to 1 by 2, your values of x are pi by 6 and 5 pi by 6. So these are your critical points: pi by 2, 3 pi by 2, pi by 6 and 5 pi by 6. Now plot them. Your critical points are, this was your 0, first is pi by 6, then pi by 2, then your point is 5 pi by 6, and then your point is 3 pi by 2, and finally your 2 pi. So these are your points on the number line. Now you need to check the value of derivative in this, in the left and right side of pi by 6. So put any value to the left of pi by 6. Put any value to the left of pi by 6. You will find in this region the sign of derivative is positive. Put any value here between 0 and pi by 6. You will find the sign of derivative is positive. Here you will find the sign of derivative is negative. Here you will find the sign of derivative to be positive. Then in the next you will find it to be negative, and then in 3 pi by 2 to 2 pi you will find sign of derivative to be positive. That was the condition required. So the intervals are 0 to pi by 6, pi by 2 to 5 pi by 6, and 3 pi by 2 to 2 pi. So you can go by this as well. So your correct option is option number D. Next, you are given two functions fx and gx. You are given two functions fx and gx. This is the largest integer function, not exceeding x. Basically this is nothing but greatest integer function, and we have to evaluate these four options. So since they have not given whether they will be correct or incorrect, or how many will be incorrect or correct, we will evaluate all the four options. This is for your practice. In such kind of question, how you will approach. First, your interval is what? Your interval is 0 to 1. Your interval is 0 to 1 in first and second both the conditions. So for x to be between 0 and 1, your greatest integer function value is always 0. The greatest integer function, when your x will range from 0 to 1, it is 0. So your gx is nothing but gx is your function x only, and your fx is sin pi x. So this is simplified form of fx and gx. Now option A says gx is always less than fx in this interval. Your gx is always less than fx in this interval. So let us take a value 5 by 6. 5 by 6 is a valid point in this interval. So evaluate g of 5 pi by 6. G of 5 pi by 6 will be, g of 5 by 6 will be 5 by 6 only, and 5 by 6 is approximately 0.833. But when you put it here, your sign will be 5 pi by 6, and we know sin 5 pi by 6 is nothing but 1 by 2. Now we get g of 5 by 6 is greater than 5 by 6 of value of f at that point. So your option A is incorrect. Your option is directly incorrect from this evaluation. When you take it at 5 by 6, your option A is incorrect. Now let us evaluate option number B. So evaluate both the integral. This is nothing but your function x only. So find its integral. It will be 0.5. Your function fx is sin pi x. Find its integral. This is the formula. It will come out to be approximately 0.636. So 0.5 is always less than this. 0.5 is less than this. So option B is correct. So first you get option B to be a correct option. Let us evaluate C. C says limit of x as it approaches to 1 from positive side fx upon gx. So when your x approaches to 1 from positive side, so this is your number line, this is your 1, x is approaching to it from the positive side. So when you approach 1 from the positive side, let's say 1.01, so your greatest integer function value will equal to 1. So when you approach to 1 positive, your greatest integer function will be 1. So your gx is simplified as x minus 1. Your gx is simplified as x minus 1. So your limit is what? Sin pi x upon x minus 1. Now this is a 0 by 0, 0 by 0 indeterminate form. This is your 0 by 0 indeterminate form. Now we apply the L'Hopital rule. Whenever you get a 0 by 0 form, try to apply the L'Hopital rule. So the derivative of this will be pi cos pi x and derivative of denominator will be 1. So now evaluate at 1 positive. So it will be pi cos of pi. Cos pi is minus 1. So this is minus pi. So this limit came out to be equal to minus pi. But your option says it to be equal to minus 1. So option C is incorrect. So your option number C is incorrect. Now let us evaluate and look at option number D. It says there is a unique value of x naught in this interval such that f of x naught will be equal to gx naught. So this is the best way to do this option is by the graph. Draw the graph. In 0 to 1, your interval is 0 to 1. So your gx is simply x. So this is your gx. Y is equal to x. This is nothing but your gx. What is your fx? This is sin pi x. Put some values. When x is 0, sin pi 0 is 0. So this is 0 at 0. Now you put value x as 1 by 2. Put value of x as 1 by 2. So when x is half, this will become sin pi by 2, which is 1. That is the maximum value of sin. So at value half, let's say this is somewhere your half. The sin pi x function will take value of 1. But at half, this is taking value. This is at half comma half. But this is your sine function which is at half comma 1. Now after this maximum value, it will start coming down. After this maximum value, it will start coming down. And you have to evaluate at point 1 in the interval 1. So you put it to be equal to 1. Sin pi is 0. I know sin pi is 0. So this is your point 1 comma 0. So this is how roughly your fx will look like. So this is how your roughly fx will look like. Now it says there exists a unique x naught such that this is true. So when you see the graph of this function, this increases and then decreases, and they both are cutting each other at exactly one point. This is the unique point. So there is a unique point in this interval such that f of x naught will be equal to gx naught, and that is the unique point x naught. So your option number D is also correct. You have to analyze this option by the graph of both the functions. Now your next question is from your system of equations. It says this system has infinitely many solutions. Then you have to tell all the values of A that are possible for this to have infinitely many solutions. So you know, for infinitely many solutions, the determinant of the coefficient matrix here should be equal to 0, because this is a homogeneous system. And for a homogeneous system to have infinitely many solutions, the determinant of this coefficient matrix should be equal to 0. That is what it is written. So determinant of this matrix here should be equal to 0. Now apply the row operations. Row 1 plus row 2 plus row 3. Add all the 3 rows. This is what you will get after adding all the rows. Now a plus 2 is common in the first row. Take it out. You can take it out, and this will be your simplified matrix. Now again apply the column operations C2 minus C1 and C3 minus C1. So now you applied 3 or 2 column operations here, and this will be your simplified matrix after applying the column operations. So when you get this matrix, expand it along the first row. A plus 2 is like that outside. When you expand it along this row, you will get what? You will get 1, A minus 1, A minus 1. So this will be a minus 1 whole square. So this is what actually your simplified determinant is. Now from here you can easily solve this quadratic. Your value of a will be minus 2 and one value will be 1. So your set of values of a are 1 and minus 2. So your correct option is option number D. Your set of values for a for this system to have infinite solution is 1 and minus 2. Now we have to evaluate the limit of this. You have to evaluate the limit of this function as x goes to 0. So first check, when you take it to be 0, the numerator will be 0 minus 0 upon 0. So this will be a 0 by 0 indeterminate form. This will be a 0 by 0 indeterminate form. Now for these types of questions, when you see a denominator in a power of x and numerator as sine and cos, we always try to use the series expansion. So use the series expansion for sine inverse x and sine x. So this is the series for sine inverse x and this is the series for sine x. Also how you will get to know till what terms you have to expand the series. That is a good question and that is a question for everyone and that is a doubt of everyone. So for that you just see the denominator. The power of denominator is x to the power 3. So take the series expansion till the cube. And rest be it like that, and this is written order x to the power 5. Because why? Because the next term will have a order or power x to the power 5. So it does not matter what the rest terms are. And here also it does not matter what the rest terms are. So that's why we have taken the series expansion of this till x cube and of sine x also till x cube. Now simply put all other terms as ox to the power 5, ox to the power 5. Now simplify this. After simplification, x and x will cancel out. These two terms will get added. So 1 by 6 plus 1 by 6 of x cube and these terms of power x to the power 5. Now this will be 1 by 3 x cube plus order of x to the power 5 upon x cube. So when you take the denominator separately with both, you will get 1 by 3. Now here all terms of our power x to the power 5, x to the power 7, x to the power 9 and so on, and it is divided by x cube. So your power will be 2, 5 and so on. So the numerator will have higher power than the denominator, and when you take it to be limit as 0, all these terms will go to 0. All these terms will start going to 0. So your limit will only be 1 by 3. And since this was divided by x cube, the order will now be x squared. So that's why it is written order to be x squared. And now final limit is 1 by 3. So your correct answer to this question is 1 by 3. Let us see this question. It says fx is equal to minimum of x and x minus 2 square, and it is true for x greater than or equal to 2. For x greater than or equal to 0, then you have to tell which is the incorrect statement. So see, fx is continuous on open interval, is differentiable, f dash x exists and it is continuous. So let us see how these two functions actually behave, and then we will see the minimum of these two functions. So for these to have minimum, whenever these type of questions comes, find the point of intersection. Whenever these types of questions comes, try to find where the two functions are intersecting each other. So when you solve this expression, x is equal to x minus 2 square, point of intersection means where the two curves will meet each other, so put them equal. So this is the value at which they will be equal, at x is equals to 1 and x is equal to 4. So they are meeting at these 2 points. So now this function can be piecewise represented as, so if you want to see graph also, so this is your function x. So this is your function x. This is your function x. And your next function is x minus 2 square. So x minus 2 square will be somewhat, at 0 its value will be 4. At 0 its value will be somewhere here 4. So it will go like this. It will meet the x-axis at point 2 and then the parabola will go up. So this is how roughly this function will be. And when you expand this, this will seem to meet this parabola at 2 points, and this is your first point. From the equation it gets this point is 1 and that point will be your point 4. So these are the 2 points of intersection of these two curves. Now you have to take the minimum. So see which graph is lower. For minimum you have to see which is the lower graph, right? So which is the lower graph here? From here till this point, this graph remains down. So fx is minimum. Your function which is minimum is x. So minimum here is your fx becomes what? Your fx becomes x in the interval 0 to 1. In the interval 0 to 1, your fx is this function x, because this is lower to this function. Then from this interval till this interval, the graph that is lower is of this x minus 2 whole square. So this becomes x minus 2 whole square from 1 to 4. And then after 4, again the graph that will be lower will be of this x. So this is x when x becomes greater than 4. So that is how I have returned this function in the piecewise manner. So from the graph you can easily see how you can write this function in the piecewise form. Or after finding the intersection points, you can clearly check the behavior between 1 and 4, to the left of 1, to the right of 4. So this will be your function in the piecewise manner. Now you have to check the continuity. Continuity can be easily seen from the graph. The graph of minimum is this, and this. So the graph is not breaking at any point. This is the graph of the minimum function. So function will be continuous. And if you have to check by the definition, and go by the definition, then you will check it at point 1, because at 1 it is changing its definition, and you will check it at point 4. So from both the points you will get after evaluation that function is continuous in that point 1 as well as point 4. Or by the graph also you can see it is a smooth graph, not breaking, not dropping pen anywhere. So you will say function is continuous. So this is correct. It is asking for the incorrect option. It says fx is differentiable on the open interval 3 to infinity. Now it is not differentiable at point 1 and at point 4. Why? Because it is taking sharp turns here. At point 1 and 4, the graph is taking sharp turns, so it is not differentiable at 1 and 4. And if you want to go by the definition also, okay, it is here. Differentiability analysis. If you want to go by definition, take the derivative. Derivative of this will be 1. For this it will be 2x minus 2. And for this it will again be 1. So this is your derivative in these intervals. Now evaluate it. Check the one side derivative at the boundary points. So you will see at 1 and 4 it will come out to be not differentiable. And by graph it is easy to see because it will have sharp turns at these points. So fx is differentiable on open interval 3 to infinity. So 3 is somewhere here. Your point 3 is somewhere here. It says it is differentiable everywhere from 3 to infinity. But at point 4 it is not differentiable. So your option B is correct. It says it is differentiable on this open interval, but it is not differentiable on the open interval, and we have to tell the incorrect statement. So your B is the incorrect statement. When you check it from 2 to 3, in the closed interval 2 to 3, so your 2 will be here, point 2 will be here. From 2 to 3, the function has a smooth graph. It is only taking this value of the polynomial, and we know this polynomial is a differentiable function. So from the interval 2 to 3 it has no problem. And in the open interval 1 to 4 also, this is a polynomial function which is differentiable everywhere. So option C and D are correct. So the only incorrect option was option number B. Next, this is a matrix question and relation. So they have mixed concept used here. With the matrix, they have mixed the concept of your relations. So see what it is asking. X be the set of 2 cross 2 matrices real entries, our relation is defined on it as a subset of x cross x. So x is a set of all 2 cross 2 matrix. Relation is defined as a subset of x cross x, and relation is given in this manner, that R A comma B are related to each other if AB is equals to BA. So A and B are related if AB is equals to BA, and we have to tell which of the following is true. So let us check reflexivity first. For any matrix, reflexivity, for any matrix A is equals to A square, and this is BA, so AA is again equal to A square when A is equals to B. For reflexivity it is A comma A, so your A comma A is always in this relation. So your relation is a reflexive relation. Now for symmetry, since the condition only says AB is equals to BA, so if AB is equals to BA, let A comma B is in your relation. So by the definition of relation, this is true. This implies BA is equals to AB, and from here I can simply say B comma A will also be in your relation. So your relation is symmetric as well. We consider this to be in relation, we found BA to be in relation as well. So the relation is symmetric as well. This can be rewritten as BA is equals to AB. So BA will also be in your relation. So this is a symmetric relation. So it is reflexive and symmetric. What about transitivity? Transitivity is a trick thing in such kind of questions. So for transitivity, we will take an example. So for transitivity to be actually true, if this is in your relation and this is in your relation, then AC should be in your relation. That is the definition of transitivity, right? So consider B matrix as your best matrix, which is the zero matrix. Consider B matrix to be the zero matrix. Now since when you multiply any matrix with zero matrix, the output is always 0. So your AB will be 0, BA will be 0. So if you consider this, since zero matrix commute with all the matrices, any AB, any matrix A and C will satisfy this condition. Why? Why? Because let your A be any matrix. Let A be any matrix A, B, C, D. When you multiply this matrix with zero matrix, the final output will be the zero matrix only. And when you multiply on the other side also, when you multiply 0, 0, 0, 0 with A, B, C, D, still you will get the matrix as zero matrix. So zero matrix commute with all the matrices. You take any arbitrary matrix, zero matrix is always commutative, which means AB will always be equals to BA if B is your zero matrix. So it will satisfy this as well as this. Now select any two matrix A and B. Let your matrix A be 0, 1, 0, 0. Your matrix C be 0, 0, 1, 0. We have considered two specific matrices. Now compute. This should be in your relation for transitivity. A comma C should be an element of R. For this to be an element of R, AC should be equal to CA. So compute AC. AC will be this, CA will be this. Now they are not equal, but AC is not equal to CA. So A comma C will not be a part of your relation, and hence this is not a transitive relation. So R is reflexive and symmetric, but it is not transitive. So this is the correct option for this question. It is reflexive and symmetric but not transitive. Next question, what it says, AB be point of intersection of this ellipse. So let us draw this. Let us draw this ellipse. So this is your horizontal ellipse. This is your horizontal ellipse because the term in the denominator of x square is large as compared to the denominator of y square. So this is a horizontal ellipse, and the parabola y square is equal to 20x. So this is your parabola y square is equals to 20x. So these are the graphs or diagrams of these two, parabola and ellipse. Now we have to tell the area bounded by parabola and the line AB lies in which interval. So AB are the point of intersection of the parabola and the ellipse. So this is your point A, this is your point B. These are the point of intersection of ellipse and your parabola. they want to ask you, they are asking you the area bounded by parabola and the line AB. So you just draw this line AB, and we are asked to tell this area, we are told to tell this area bounded by this parabola and this line AB. This is what we have to find. So let us first evaluate what this point A and B are. For the limit, for the integration to apply for the area, we have to find the points A and B to apply the limits of the integration. So intersection points of parabola and ellipse. So substitute y square is equals to 20x in the ellipse equation. This is the equation of parabola. Substitute y square value. So you will get this quadratic equation in x. Apply the quadratic formula. You will get and solve it to be like this. This is how it will open as. Now rejecting the negative coordinate. Why will reject the negative coordinate? Because the parabola is on this axis. So this x coordinate will always be, this x coordinate is always positive. So rejecting the negative coordinate. That was the reason to reject the negative coordinate. So your value of x will be 12 by 10, which is 1.2. So this coordinate is, this x coordinate is, your x coordinate is, this is 1.2 comma something, and this is 1.2 comma something. Let's see what that something is actually. So that something, when you put value of x to be 1.2, your corresponding y values are plus minus root 24, which is plus minus 2 root 6. So this is 2 root 6 and this is 2 root 6. So we did nothing till now. We just did what? We just put this equation in this and found the point of intersection, which came out to be 1.2 for x values. When you put this value here, you will get value of y to be plus minus 2 root 6. So the line AB is the vertical line, x is equal to half. So what is this line y now? This line AB, this is a vertical line, this is your point A, this is your point B. Equation of a vertical line is its x coordinate, which is 1.2. So the equation of this line, this vertical line, is x is equal to 1.2. So the equation of this line is 1.2. Now we have to compute the area. Area enclosed between the parabola and vertical line. So we have to compute the area between this and this. So you can see this is symmetric, right? If you see in the big picture, this is now this and this line, and this is your x-axis. So you want to evaluate this complete area. This is your line, x is equal to 1.2. This is your equation of parabola, and you can see it is symmetric about the x-axis. So just consider and evaluate this area and double it. Just calculate this and double it. So you have to evaluate this area. Your limit of x will run from 0 to 1 by 0 to 1.2. Your limit of x will be from 0 to 1.2, and the equation will be for the parabola. So it will be from 0 to 1.2, twice it, because we are just taking the symmetric case. So 2 times from 0 to 1.2, and the equation is root 20x. Y will be root 20x. So now evaluate this, find this integral. The area will come out to be this after your calculation. Simplify this, and you have to tell the interval for this. So just use your calculator, which is provided to you, and it will approximately come out to be equal to 7.838, which lies in the interval 7 to 8. So the correct answer is option B. Next question. A spherical ice ball is melting in such a way that its radius is decreasing at a constant rate. So it says the rate of decrease of radius is constant. So it is given dr by dt is a constant. So the first information from the question is the rate of decrease of radius is constant. Now what should be the radius of the ball so that rate of decrease of volume is equal to rate of decrease of surface area. Now here the important term to note down is it says numerically equal. By numerically it means mod value. It does not ask you the negative value, it just says numerically, that means the positive value only. So let V be the volume and S be the surface area. So the formula for volume of sphere is 4 by 3 pi r cube. Rate of change of volume, calculate it, apply the chain rule. So dv by dt will be 4 pi r square dr by dt. And similarly, your surface area for sphere is 4 pi r square. So apply ds by dt will be 8 pi r dr by dt. Now it says equating magnitudes. See, it says equating magnitude. Why? Because it said numerically. So by numerical it means only the total magnitudes. So magnitude of this term is equal to magnitude of this term. Now since 4 pi and r square are positive, they are outside the mod. 8 pi and radius is always a positive quantity, positive number, so it is outside the mod. It becomes mod of dr by dt and mod of dr by dt. Why? Because it is decreasing. So this was negative actually. This was a negative quantity, but it just asked numerically value. So mod of dr by dt, mod of dr by dt. Now since this is a constant, it is a non-zero constant because it is decreasing with time, so it cannot be equal to 0. Then it will again, radius will become a constant only, right? If let's say if dr by dt is 0, this simply implies radius is a constant. So radius will not decrease, right? So this is contradicting it. So this is a non-zero quantity. So this is non-zero. So we can cancel them on both sides since this is a non-zero quantity and radius is positive. So dividing both sides by, or you can cancel simply, you can simply cancel pi with pi, r with 1 r, 8 with this 2. So this will simply cancel out and that will give you radius equals to 2. You just divide or just simply cancel them. So your radius will come out to be 2. So your value of radius is 2, which is option A. So this was an easy question. I would say this was a very easy question if you just read this carefully. Next question. It says 3 different numbers are chosen at random from this sequence. So 3 numbers are randomly chosen from 1 to 5 and then arranged in ascending order. So you have to tell the probability that resulting sequence is in ascending order. So what we will do? We will first randomly choose 3 numbers and then we have to see and arrange them in ascending order. And we have to tell the probability will be in ascending order. So first what is our outcome? Your total outcomes are 3 distinct numbers from the set. Why? Because it is asking you to choose 3 different numbers. So first our sample space becomes choosing 3 distinct numbers from this set. So how many ways are there to choose 3 different numbers from 5 numbers? That is 5p3. That is 5p3. You can choose 5 numbers from these 3, and since we have to arrange them also, that's why we are taking permutation. Since we have to arrange them in a sequence also, we are taking a permutation. So the permutation in a sequence will be 5p3. So that is equal to 60. That is equal to what? That is equal to your value 60. Now our favorable outcomes. Favorable outcomes are of ascending order. So our total outcomes, don't get confused here. Total outcomes are to choose 3 different numbers and arrange them in a sequence. And because we have to tell them they are in ascending order or not. So sequence matters here. So whenever sequence or arrangement matters, we always calculate the permutation. So choosing 3 numbers from 5, the permutation is 5p3. So we have 60 ways to do that. Now favorable outcomes are, we require resulting sequence to be strictly increasing. We want that to be in strictly increasing order or ascending order. Now for any unique 3 numbers, when you select 3 numbers, select any 3 numbers. Let's say I select 1, 3 and 5. Now these 3 numbers to be in ascending order, there is only one way. You can only arrange them in one way. You can arrange n numbers only in one way so that they are in ascending order. So there is only exactly one unique arrangement that satisfies this condition. So favorable combinations, your favorable outcomes are 5c3. Your favorable outcomes are 5c3. You can only choose 3 numbers out of these 5. After that you have no free will. After that you have no free will to actually arrange them in any possible way. So we get 5c3. So when you do that, your 5 C 3 will come out to be equal to 10. Now these are your favorable outcomes, these are your total outcomes. So our condition is probability of event T, which is number of outcomes of event T, and this is number of outcomes of favorable total. So this will be 10 by 60, which is 1 by 6. So the correct answer is option number D. So the correct answer is option number D, which is 1 by 6. Next come up. The two lines are coplanar, you have to just find the value of lambda. So if you know the condition for coplanarity, if you know the condition of coplanarity of two lines, then this question is nothing for you. This question is nothing if you know the condition for coplanarity of two lines. So for two non-parallel lines, you can easily see these two lines are not parallel because their ratios are not same. The ratios, direction ratios are not same, so they are not parallel. For the two parallel lines in the Cartesian form to be coplanar, shortest distance between them should be 0. So two lines are coplanar if the shortest distance between them is 0. And by the distance formula, this is the shortest distance formula in Cartesian form, this should be equal to 0. Now for line 1, it passes through, the line 1 passes through 3, 1, 3 and has direction ratios lambda 2 and minus 1. So it passes through 3, 1 and minus 3 and has direction ratios lambda 2 and minus 1. Similarly for your second line, this passes through 3, 2 and 1. It passes through 3, 2 and 1 and has direction ratios as lambda 3 and 4. So the direction ratios are lambda 3, 4. So just substitute all these values here. This is your x1, this is your x2, y1, y2, z1, z2. Substitute them here, L1, M1, all these values. You will get this matrix condition for coplanarity. You will get this matrix condition for coplanarity. Now expand this along your first row. This is what you will get. When you expand this along your first row, this is what you will get. Now simplify this, you will get lambda to be directly equal to 0. So this was just required to know, this was just the required condition that you should know for the two lines to be coplanar. So the correct option is option number B. The value of lambda is 0. Next, ABC are three non-coplanar vectors and PQR are vectors defined by this relation. So you are given ABC to be as three non-coplanar vectors, PQR are any vectors which are defined in this particular manner, and you have to find the value of this. We have to find the value of this complete expression. Now see, this PQR are called up, this PQ and R are called a special, they are called a special term, they are given a special term. So PQR represents a reciprocal system of vectors. So they do what? They represent a reciprocal system of vectors with respect to A, B and C. If you see such vectors written, you can directly say they represent a reciprocal system of vectors and they satisfy these two conditions. If you see a reciprocal system of vectors like this satisfies these two conditions. First is orthogonal property, or the cross product of a vector with itself or any component is always 0. Orthogonal property says if you have these kind of vector, if you take its cross product with itself, which means if you take cross product of this with this only, it will be 0, or its constituents. What are the constituents of this P? It is B and C. So if you take the dot, if you take the cross product, if you take the cross product, here it will be cross product. Here this would be, here it would be the cross product of a vector with itself, or its constituent product is always 0. So right. So when you do that, you get B dot P is equal to B dot B cross C upon this. This is your vector P. So when you do that, you will get to be 0, 0 and 0. So when you dot product it with B, you will get it to be equal to 0 because it is its constituent. It is its constituent. So when you do that, you will get it to be equal to 0 because your B cross C vector will give you some vector in terms of A, and then B dot A will be 0. and this is what you will get. And then normalized properties. Now when you use the scalar triple product cyclic identity, we have this identity that ABC, the scalar triple product is equal to BCA, and this is equal to CAB. This is the cyclic property of scalar triple product. So when you do that, you will get A dot P is equal to 1, B dot Q is equals to 1, C dot R is equal to 1. So these are the properties that are satisfied by this reciprocal system of vectors. Now just simplify the expression. Your expression simplifies as A dot P plus B dot P, A dot P plus B dot P, B dot Q plus C dot Q, B dot Q plus C dot Q, A dot R plus C dot R. This is the simplified expression. And now just using these properties, you can simply evaluate that A dot P is 1, A dot P is 1, B dot P is 0, B dot P is 0. So you will just evaluate this and you will just put the values from here. You will get the final expression to be equal to 3. So the value of this is 3 and your correct option is option number C. Now let us look at your next question. It says A and B are two 3 cross 3 matrices such that they commute. AB is equals to BA, that means it is commutative, and A square minus 5AB plus 4B square is equals to 0. And the second condition is this expression is equal to 0, where 0 is the 0 matrix. Then you have to tell which of the following option is actually correct. You have to tell which of the following option is correct. So let us evaluate the option. Now since this is given to you, and AB is equals to BA. Now you are given what? You are given A square minus 5AB plus 4B square is equal to 0. So you can expand this as A square minus AB minus 4AB plus 4B square is equal to 0. Take A common here, it will give you A minus B. Now since AB is equals to BA, I can replace this by 4BA plus 4B square, and I can write this equal to 0. So from here I'll get A minus B minus 4, B I'll take common, this will give me A minus B is equal to 0. So from here you can factorize, write it in factorized form as A minus B, A minus 4B is equals to 0. So this is directly what is written here. Since AB is equals to BA, that we applied in this step. AB is equals to BA, we applied in this step. So we can get this as A minus B, A minus 4B is equals to 0. Now since what option B says? It says A and B are non-singular if any one of these two matrices non-singular. What does it mean by non-singular? Non-singular means the determinant is not equal to 0. So let us assume first A minus B. The first A minus B matrix is non-singular. Now since it is not singular, its determinant is non-zero, it is invertible. Its inverse exists. So multiply both sides with its inverse. So this will be A minus B inverse into A minus B, and A minus 4B is equal to 0. Because inverse multiplication here does not matter, it will give you 0 matrix only. Now this inverse into this matrix will give you identity matrix. So you are left with A minus 4B is equals to 0. So A will be equal to 4B. So when you solve this, you will get A is equals to 4B. Also, then A minus B will be equals to 3B. When A is equals to 4B, just substitute A as 4B. You will get A minus B is equals to 3B. Now in the question it was given A minus B was a non-singular matrix. In this we assumed A minus B is non-singular. Because we are given either one of this is non-singular, we have to assume that. So let us assume A minus B is non-singular. So A minus B is non-singular, which means 3B is not singular. Now when 3B is not singular, it means B is not singular because 3 is just a constant number. So when B is non-singular, then your A is equals to 4B. A is equals to 4B is also a non-singular matrix. So when we have considered A minus B to be non-singular as per the condition given in option number B, I got A and B both to be a non-singular matrix. So this is true till now. Let us see when a minus 4b is non-singular. Similar case, when a minus 4b is not singular, then you can multiply both sides of this expression with a minus 4b inverse. Similar to this process, you just multiply with a minus 4b inverse. So when you multiply it on this side, what you will get? This was a minus b, a minus 4b. You multiply here with a minus 4b inverse, and here it will be your 0 matrix. Now, a matrix with its inverse will give you identity. So, you will get a minus b is equal to 0 matrix. From here, you will simply get a is equals to b. So, your second equation simplifies as a is equals to b. Now, when a is equals to b, when a is equals to b, and it was given considered a minus 4b is non-singular. When a is equals to b, your a minus 4b will simplify as minus 3a. When a is b, put this as b or this as a, you will get this to be minus 3a. So this is non-singular because a minus 4b was non-singular. So this is non-singular, so a is non-singular, and when a is non-singular and a is equals to b, so b will also be non-singular. So when this is also non-singular, both a and b are non-singular. Non-singular simply means that the inverse exists or the determinant is not 0. So if any one of this or this is non-singular, both a and b are non-singular. So my correct option is option number B. You can easily check other options by taking a particular example or by general theory if you have studied matrices well. And so that was it. That was your 50 most important questions for your next exam. And thank you everyone and have a good day. Thank you for watching this and I hope you all the best for your exams. Good luck. Wish you every success in your life. Thank you everyone.